Hello, good evening. Okay, so let's start. Today we are going to start a new lesson, vectors. And I think you can hear me. Um, yeah, okay, good. Hari. Okay, so today I think up to this point you learned the basic concepts like units and dimensions and some measuring equipments. So that's about the basic stuff. Okay, so now we are going to a new part. Starting from today we are going to real physics. The vectors, actually vector is a part of first lesson, but that is the starting of the real physics. Okay, අද හොඳ නෝන තියාගන්න අද ඉඳන් හරි තමයි අර if you have previous experience like any comments or any feedback from the previous students like any seniors. Okay, so then sometimes they are saying the physics is a little bit hard. Okay, so that's now we are going to that level with these vectors for the calculation. Up to this we didn't do any calculations, just learn theories, but today, starting from today, you can see we are going to discuss real calculations. So always think that always try to do the homework within that day. So I think I have the Sinhala medium tutor. English, I think hopefully you need to get this one by now, the English medium one, yellow color, this one. Okay, vectors. I have the Sinhala medium one. Yeah, Anuradha Sinhala. Okay, so yeah. Okay, let's start. But I'm not following the same order. I'm doing it a little bit different, but the same content. We are doing the same content. Physics one physics. Sorry, there is no any other thing. I'm not going to discuss deep concepts like vectors if you are doing engineering or mathematics. If you are doing L mathematics, we are doing some mathematics. There is another lessons known as vectors, similar thing, but we are in maths. You are learning some additional like more in deep theories, but if you are going to do engineering, then you can learn vectors in I mean you can learn the way that we are using vectors in real calculation. Okay, yeah, good. හරි එහෙනම් වැඩේට ලෑස්තිද? අද සුපිරියක් කරන්න ඕන. හරි අද ඉඳන් හොඳම තියාගන්න මේක කරනවමයි කියලා හිතලා. හරි homework ටික මම සිංහලෙන් කියන්නේ මොකද අපි අද පටන් ගන්න අලුත් සැඟකට යන්න හදන්නේ අලුත් dimension එකකට යන්න. Not the dimension we learned. We are going to new concepts, new part of physics. So try to complete that one and don't miss the class. I mean, now you know the recordings are there, but always try to join with the live sessions and get the maximum benefit of the live session, because you can clear all your doubts within the class. And yeah, you can chat with me. Chat is there. Yes, you can chat. And that's about the starting of the today class. If you have any comment, you can ask me. I mean, my feedback, and starting from today, I'm going to give you a 10 minutes break at 10 a.m. At 10 p.m. Sorry, my bad. 10 p.m. Okay. අපි පොඩි විනාඩි 10ක් break එකක් ගමු. I know that's very hard to stay continuously for hours. Definitely, I'm giving 10 minutes break. Okay. මම දෙනවා. Yeah. Okay, good. So let's 10 minutes at the end. You can just take 10 minutes break. Okay. එහෙනම් දාගමු vectors. So write the heading vectors. Vectors. හරි ලස්සන පාඩම් හරි. Vectors. So this is the last chapter of the first lesson. This is the last chapter of the first lesson. This is the last chapter of the first lesson. Okay. Vectors. Okay, before going to vector, I think we know, I mean, you know, probably now up to this point, we learn about different properties, different units, and you know, there are several properties in this universe, okay, in this physics world, there are so many physical quantities. Out of that, there are scalars and vectors. What are those? Okay, so when you take any physical quantity, it can be either a scalar or a vector. So what is a scalar? What is a vector? The first thing we need to discuss is what is a vector? Do you have any idea about vectors? Because these are fundamental things. You are learning these things in A level, not A levels, O levels also. Okay. What is a vector? What is scalar? Okay. So first thing, you know, there are so many physical quantities in this universe. Okay, as I mentioned, and we learned some of that during our units and measurement part. And there are 7 basic properties, and then there are derived properties. Having I mean derived one, you know, when you learn the units, we learned compound with compound names and specific names, special names. Likewise, we have derived properties and supplementary properties units for plane angle, like that. And allowed units, there are so many properties, you know. So out of that, what is a scalar, what is a vector? Okay, so when you check a physical quantity, whatever physical quantity, you know, let's take as example mass. Okay, mass. So if you measure the mass, so I'm going directly to the lesson. Hari දැන් වෙන කතන්දර නැහැ. කෙලින්ම පාඩමට තමයි යන්නේ. වෙලා නැස් ගන්න ඕනේ නැහැ. හරි. අතරමැදි පොඩි අනම්මනම් ටිකක් කියන්න. Okay, so what is a scalar, what is a vector? Yeah, so when you take a mass as simple example, mass. Okay, so when you take mass, no need, so some let at all time let take that mass. So if you are asking the mass of a body, mass of object, then you are just describe that one using a number. You can describe the mass only using a number. 60 kilogram, 50 kilogram, 100 kilogram. If you want to measure time, 60 seconds, 20 seconds, 2 hours, 3 days. Okay, likewise, you have a number. You can represent that value using a number only. Okay, another important thing, speed. An example. So now when you take the speed, then okay, so now imagine this situation. Then me subject I'm doing a special program to cover up the mathematics also. I'll tell you about that date, about some basic mathematics. Yeah. Then now important thing is when you work with these physics or the future content, always you need to develop your brain power or thinking power or imagination power. Imagine it. Then when I'm explaining something, you need to imagine, you need to visualize that one in your head, the visualization. When you are doing mathematics, there are magnetic lessons, then you need to improve your 3D visualization. 3D wise, you need to observe what's happening there. But up to now, 2D visualization is sufficient enough, but we need to develop 3D visualization also. If you are doing engineering, most of the time we are going for 3D. ඔගොල්ලෝ ඇඟට දැනෙන්න ඕනේ 3D විදිහට. මොකක්ද ගානක් හරි ඇඟට පේන්න ඕන 3D ඇදිලා මැවිලා පේනවා. හරි. Okay. Okay, now when you take, pay your attention. These are very important thing. So now I'm taking the same example. Let's say there is a moving body. You are observing a moving body, and there is a moving vehicle. Then ඔයා ඉන්නවා ඔයාගේ යාළුවා ඉන්නවා. ඔයාගේ යාළුවා ඉන්න. There are two people, you and your friend. Okay, so your friend notice a vehicle passing close to you and your friend. There is a moving vehicle passing to you, and you are describing, or let's say your friend is describing to you. Your friend notice a moving vehicle, and your friend try to explain that one is a very what we unique car. Anna Lamborghini gaggiya. Likewise. Okay, so let's say there is a unique car. Your friend explaining about that car to you. So that person explain that Lamborghini moves 20 meters per second. හරි අන්න 20 නෙමෙයි 20 නෙමෙයි 20 you are not familiar with the 20 meters per second not in day like අපි කියමු 100ට ගියා හරි අන්න Lamborghini එකක් ගියා 100ට එහෙමනේ කියන්නේ අපි හරි when you are day verbs we are not talking about the meters per second හරි always we are using kilometers per hour so your friend is saying like that car moves 100 kilometers per hour 100 kilometers per hour okay කපාට ඔයාත් බලනවා හැබැයි ඔයාට information එකක් මදි දීලා තිනවා what is the information so you are getting information from your friend and but there is a missing one to now you need to දැන් ඔයාට සද්දේ හරි අපි කියමු සද්දේ හෙන්නේ you are wearing the you are not concentrating about that moving car so you are not getting the sound so but now you need to check that thing you need to check the direction simply හරි දැන් ඔයාට දෙනවා දැන් ඔයාට බලන්න හිතෙනවා බලන්න ආසයි ඕකේ කොහෙද ගියේ කියලා හරි your friend is saying there is a moving Lamborghini to I mean with 100 kilometers per hour so then you also like to see it but that information only indicating a value then there is missing data the direction yes I can see your answers the direction so that means that answer doesn't include the direction lack of information okay so if that one only gives the magnitude known as scalars තේරෙනවා මං කියන එක ඒ යාළුවාට දුන්නේ මොකද්ද magnitude එකක් විතරයි that person only gives the magnitude only those are known as scalars that means there is small but for some cases that's enough කොහෙරට ගියා ප්‍රශ්නයක් නැහැ යන දිශාව වැඩක් නැහැ no need to worry about the direction you sometimes for some cases the magnitude is enough okay but for that previous example if you want to see it you need to check the direction to which direction you need to උඩටද ගියේ පල්ලෙහාටද ගියේ කොහෙටද හරි you need to check the direction I mean if you want to observe it so that person need to tell you there is a moving Lamborghini with 100 kilometers per second to the let's take north side or south or left side on you, according to your position you can say that one moves to the let's take you are sitting I don't know your current location maybe let's take example ඔයගොල්ලෝ හැමෝම දැනන තරම it's very hard to take an example maybe I'll take Petai station නේ Petai හරියන්නේත් නැහැ let's take what you know about Colombo Port City ඒකත් දන්න අයලා තියෙනවා most of the time you know about the CCC හරි අපි CC එක ගාව ඉන්නේ හරි maybe නෑ අපි කියමු one goldfish හරි most of the students they are coming to Colombo and go to the one goldfish හරි බලන්න යනවනේ so let's take you are standing in front of one goldfish so your friend is saying there is a moving Lamborghini to which direction so let's take other side the mountain side I mean the Moratuwa side there is a moving vehicle to the Moratuwa that side Moratuwa තියෙන අනිත් පැත්ත කොළඹ පැත්තට නෙමෙයි අනිත් පැත්ත හරි so then your friend can say there is a moving vehicle there is moving Lamborghini to the Moratuwa direction to the gold side okay so then you can just check you can just turn and check the direction and with the sound you can also notice it but later you are not concerning and somehow with the information your friend is providing you can just check it so that one is the vector is a property having the magnitude as well as the direction okay so if you are only giving the magnitude that one is known as scalars හරි lazy physics කියනවා lazy subject හරි හොඳට ඉගෙන ගන්න පොඩි දෙනින් පටන් ගන්න ඔයගොල්ලෝ හිතනවා අයියෝ මේවා දන්න දේවල් මේවා කියන්න දෙයක් නැහැ මොනවද මේ හරි අහගන්න එහෙම තමයි let's start from the basic concepts and let's move forward okay ඒතකොට දන්නේ නැති කෙනා දන්න කෙනා ඔක්කොම මේවා පුළුවන් වෙනවා දන්න කෙනාට හොඳටම පුළුවන් වෙනවා දන්නේ නැති කෙනාටත් පුළුවන් වෙනවා okay so remember the concept when you take scalar the magnitude then those are known as scalars and if you take the magnitude and the direction both together known as vectors okay so vectors we are learning about vectors the vector Okay, මෙහෙම දාගමු. Under that first we are, the heading is vectors. Okay, but for before going to vector, let's identify what is scalar. What is scalar? So write down the first one, first heading, scalar. Subheading, scalar. Scalar. ඒකට සිංහලෙන් කියන්නේ අදීශ කියලා. හරි. අදීශ රාශි. Scalar. So what is the scalar? ලියන්න එපා. හරි. A scalar is a physical property having the magnitude only. Having the magnitude only. Or we can describe the physical property, or there is a physical property which we can describe using the magnitude only. දැන් උදාහරණයකට time එක ගත්තොත් direction එකක් නැහැ. හරි. When you take temperature, there is no direction. So we can describe that property using the magnitude only. Okay, so write down that one. A physical property which we can describe, a physical property which we can describe or represent, describe or represent. Describes, which we can describe, represent using the magnitude only. A physical quantity which we can describe or represent using the magnitude only is known as a scalar. Is known as a scalar. A physical quantity which we can describe or represent using using the magnitude. Vishalatve. Magnitude. Okay, magnitude only is known as a scalar. A scalar. Okay, I'll give you some examples after defining the vectors also. Then we can take a table, scalar quantities and vector quantities. Okay, so now you can write again subheading vectors. Yeah, let's try that. Vectors. Okay, vectors. So scalar, you can describe or represent that one using the magnitude only. As I'll give the set of example as a table after this definition. Like time, mass, current, like that work, energy. So other one is vector. A vector property. What is a vector property? Hi. So just here first, a physical quantity which we can describe or represent by the both, using the both magnitude and the direction. You need the both. Okay, so let's take your explaining that same previous example. There is a moving Lamborghini to there's a moving Lamborghini with 100 kilometers per hour. There is a lacking information. You need to give the better idea. You need to represent direction also. You don't know what's happening. If you let's take now, I am applying a force 10 Newton. Then you are asking again question to which direction? So I am applying force. Then you are again asking which direction? What is the direction of the force? Because that one needs direction also. If I am explaining If I take another example like you know about the force, momentum, like there are so many properties. Let's see. Yeah, write down the definition. Vector, a physical property, which we can describe or represent a physical property which we can describe or represent. Actually, which we can name it no, right? You can, which we need to describe. That one you need, not can, you need. There's a difference between you need to do that. Well, you need to do that. Okay. Come on, you can a physical property which we can describe, which we need to describe or represent using the both magnitude and the direction. Both magnitude and the direction. Using the both magnitude and the direction. And okay, and both magnitude and the direction is known as a vector. Is known as a vector. Okay. A physical quantity which we can describe or represent using the both magnitude and the direction is known as a vector. Is known as a vector. Okay. So let's get an idea about the difference between this one. So let's take, there is a moving car. මම මේ Lamborghini එක නෙමෙයි අඳින්නට අඳින්න පුළුවන් කමන්නේ අපි අඳිමු පරණ කාර් එකක්. Okay, so let's take, there's a moving car. If you prefer, you can draw whatever you want, doesn't matter. Okay, so let's take that there is a moving vehicle. So now I'll take that one as the whatever reference. Okay, you are taking what do you like to do? Let's take that. Okay, I'm taking Nelunkurana. I mean, everybody knows this location. Otherwise, when I'm explaining these things in Nugegoda or nearby area, then I'm taking nearby location. But since this class, there might be students coming from different locations, so I need to take different, not different, unique place. Let's say there is a Lotus Tower. කොහොමද ඒක අඳින්නේ? ඔන්නෝම තියෙනවනේ. මතකත් නෑනේ. හැමදාම දකින්නේ නෑ. Okay. Okay. ඔන්නෝමනේ තියෙන්නේ. So this is the Lotus Tower. Don't think about the scale, the size. Okay, I'm just drawing the reference point. Okay, because I need a reference point. Related to reference point, I can explain the direction easily. Okay, so then this is my reference point. You will learn this one in the linear motions. Okay, so what is the reference point? Reference point is a known point. Everybody knows that point. Then you can give the coordinates or location related to that reference point. Then හිතන්නකෝ මම ඔයගොල්ලන්ට කියනවා හරිද? Let's take as an example, I'm taking කවුද මම හිතන්නේ? Let's take Liberty Plaza. And if you know the place position, then I can give you the coordinates of my current location relative to the Liberty Plaza. But if you don't know, then uh, it's not good. I mean, it's not successful. My coordinations are not successful because you don't know. Hari. But if you know the lotus, කොහේ තියෙනවනේ. උසට තියෙනවනේ. Hari. එතකොට then you can refer that one and then you can identify my location. Okay. So let's say there is a moving vehicle to which direction අපි දන්නේ අපි හිතමු then here if I indicate the 100 kilometers per hour then there is a lack of data, that one known as speed. This one is known as speed, the magnitude. But if you indicate the direction, hi, then that one is as together, I mean both together we can describe as a what we call the vector. Hi. So we can take, if you take these two as a one common term, then it is a vector. Actually this is the velocity. Hi, දාගන්න පොඩ්ඩක් කොහොමද the difference between those two is a vector property, velocity. If you take the magnitude only, if you take the magnitude only, and if you take the magnitude only, then it's known as speed, then it's a scale property. Okay, just write the some idea, you can get an idea about the vector and the scalar. Okay. I'm taking reference point related to that one. I can explain directions. It's moving to the right side relative to the reference point. Okay. Speed is just the magnitude, but if you indicate the direction, it's a vector known as velocity. Okay. So now let's take some examples. මෙහම දෙපැත්තට පොඩි chart එකක් ගමු, scalar and the vector. Examples. මොනවද? What do you know about scalars? We can write, we can take mass, distance. Distance के දුරක් විතරයි. ඔයා දන්නේ මම කොහෙටද ගියේ? මම කියනවා ගියපු දුර. I traveled 10 kilometers today. To which direction? You don't know because I'm not providing that data. That is distance. Mass, distance, then time. Don't write weight, okay? Weight and mass are two different things. සිංහලෙන් කියන්නේ ස්කන්ධය සහ බර. Mass, just the mass. That one depends on your physical body or physical object. The mass, that is the amount of or matter, not amount of matter, that is the moles. I mean, due to the size or due to the physical appearance, the mass depends, distribution, particle distribution. The weight is depends on the gravity. Okay, weight is a force. Weight is a force. So mass, distance, time, speed, then temperature. මම නිකන් අමතර දෙයක්, හරි අමතර දෙයක්. Scalar, vector, තව එකක් තියෙනවා. හරි. So when you take vectors, those things are not teaching in the A level stuff, A level mathematics also. There are some rank, there are some orders. You can size එක vectors වල හරි අපි 1D 2D කියලා. This is 1D. 1D means only the magnitude. This is 2D, the magnitude and the direction. So there are some other concepts like you need to represent one magnitude and the two directions. So likewise you can stack so many informations. Then it is known as what we called මේක තිබ්බේ නමින් පොඩ්ඩයි නම් තුනන හරි give me one second. Hi, not a vector. So that is a we don't need additional information. Higher level, හරි higher level මම නිකන් ඔයගොල්ලෝ දැනගන්න කියන්නේ හරි that one is tensor ඊළඟට එන option එක tensor ඊට මේකට වඩා ඉහා ගිය එකක් is another extreme condition, not extreme, high level condition than the vector. You need so many information to describe a tensor. Okay, tensor උනම් ගහලා බලන්න tensor කියලා Google කරලා හරි tensor in physics කියලා ගහනවා එකේ කියවෙයි නැත්තම් tensor. Okay, tensor is a mathematical object to use to describe physical properties that vary depending on directions. හරි scalars magnitude only, vectors magnitude and direction. If you take multi-dimensional arrays of numbers whose value remain independent observer coordinate systems, so yeah, so if you want to represent multi-dimensional arrays, multi-dimensional ගොඩාක් dimensions ගොඩාක් තියෙනවා හරි so then it's go for the tensor හරි ඒක ඕනේ නැහැ additional thing, no need to write that one. We have another thing known as tensor. Okay, we can learn about the scale and the vector. ඒක ඇති අපිට වැඩි දේවල් ඕනේ නැහැ. තියෙන ටිකක් තාම අමාරුවෙන් ඉස්සරහට ඔයගොල්ලෝ අල්ලන් ඉන්නේ. හරි. Okay, so write down some other information, other examples: mass, distance, time, speed, temperature, electric current. Normally අපි current එක එන්න කලින් work energy ලියලිමු. හරි. Work energy කිව්වම you don't need the direction. හරි. Just take the energy. There is no පොඩින් work එකට work නෑ work එකකට නෑ work එකකට නෑ work no yes then work energy තාම work එකක් කරාම මෙච්චරයි direction එක කරන්නේ මම කරා work එකක් හරි work energy area volume ලියන්න දෙයක් නෑ if you want you can write area volume density ලියනවා ලියත හැකි ගමක හරි density area volume වැදගත් දේවල් ටිකක් ලියන්න නැත්නම් මේ තේරුම් ගන්න ඔක්කොම ලියන එක හරි so just no need to write that one on the same line. Okay, I'm giving so many things, you can just write using commas. මම ලියන් comma දාගෙන ලියාගෙන යන්න නැත්නම් dots දැම්ම නම් dots write in the two columns නැත්නම් ගොඩක් තියෙන අපරාධ පොතේ ඉඩ. Okay, then area volume තාම මෙන්න මේක electric current. Normally electric current, potential, resistance, all these things are electric current. You know the direction. That direction depends on the way that we are applying the EMF or the battery. Electromotive force කියලා ඇත්තන පස්සේ කියනවානේ. හරි a battery. So there is a current direction here. Current is flowing or current is normally considered as the positive charge flow, but that one depends on the battery we are the way that we are connecting the battery. Okay, so still that one is a scalar. Electric current. Then this one pressure. Pressure pressure is a scalar. Pressure is a scale. Why is that? මොකද දැන් හිතන්න හොඳ එක්සැම්පල් එකක් කියන්නම්ම හරි so පේනවනේ උඩ ටික if you need more time to write down the above one you can take it. දැන් හොඳ අහක පොඩි උදාහරණයක් අහන්න. දැන් හිතන්න මෙහෙම දෙයක්. හරි මම මේ එක්සැම්පල් එක කියන්නේ purely based on physics. Okay, So now let's take there is an object. There is an object. That object, um, let's take that object moving. හරි අමාරුයි ලස්සනට කියන්නේ. හරිද? අපට මෙහෙම හිතමු. ඒ object එක හරිද? allow a certain service. හරිද? To allow a certain service to anyone. I mean, හරිද? Okay. So you can say there is a object. I mean, there is a what we call, don't think about, හරි මේව හිතන්න එපා. මේ කියන්නේ මොකක් හරි තියෙනවා service එකක්. That service is provided to any person. Okay. So then that the uniqueness, there is no uniqueness there. දැන් හිතනවා අපි කියන්නේ සිංහලෙන් අගයක් නැහැ, no value. I mean, if you want to improve your demand, I mean, if you want to improve your professionalism, or if you want to improve your character building, so then you need to have a certain unique identity. අපි කියන්නේ හැමෝටම ඒක ලේසියෙන් ගන්න පුළුවන් දෙයක් වෙන්න හොඳ නැහැ. හරිද? මම මේ කියන්නේ තේරෙනවද? හැමෝටම ඒක ලේසියෙන් දෙන්න හම්බ වෙනවා නම් අගයක් නැති වෙනවා. තේරෙනවද මම මේ කියන එක? හරි. If others can't reach you, and then you have a certain value. And pressure වෙලා තියෙන තේ වැඩි. හරිද? Pressure වෙලා තියෙන තේ වැඩි. Pressure, you know, when you apply a force per unit area, there is a pressure. But pressure is acting, the direction is acting to each and every direction. හැම පැත්තටම act කරනවා. ඒකට වැඩි act කරනවා. හරිද? So when you take hydrostatic pressure, whatever pressure, that pressure is acting in each and every direction. හරි. ඒතර මෙයාට කිසි වැඩක් නැහැ, value එකක් නැහැ. Direction එකේ. That one is acting to each and every direction. Because of that, there is no importance to describe the direction, because that one is acting to whatever direction, to any direction. පේනවනේ value එක නැති වෙලා කියන. හරි. ඔයගොල්ලෝ ජීවිතේට physics. හරි. You need to apply those things in your real world life also. When you are doing anything, or if you are targeting any what you call the future plans, always try to be a unique person, and everybody can't reach you. Again, you need to build up your character, that you need to have a demand, and yeah, that's the concept. So then there is speciality, there is uniqueness, and you can say there is the importance of describing direction. Then force එකට හැම වෙලාවෙ force එක එයාගේ පාඩුවේ ඉන්නවා force. එයාගේ demand එක නැති එයාගේ තියෙන අපි කියන්නේ අර power එක නෙමෙයි, not the power, but simply there is a certain value for the direction. But here the pressure එකට වෙලා තියෙන හැමතැනටම වැඩ කරන්න කියලා අනාගෙන තියෙනවා. Okay. Yeah. හරි. Okay. හරිනේ, මම purely based on physics, okay, not any other thing. Yeah, scalar vector. So pressure is something like that. Pressure is acting to each and every direction. So no need to represent direction there. හරිද? Okay. And then tensor is a different thing. You can consider that is an extreme level of vector. It's not a scale. Like මම නිකන් අමතර දෙයක් කිව්වේ. හරි. It is another level of vector. Like a vector එකේම higher level. You need more information to represent a tensor. Tensor example එකක් තියෙනවා stress කියලා. Stress කියන්නේ ඔයගොල්ලෝ දන්නේ stress එක නෙමෙයි. හරි. අනේ මට හරි stress. විභාගෙ ලඟ වුණා එහෙම. එහෙම කියාගෙන ඉන්න එපා, stress නැහැ. එහෙම එකක් නැහැ ලෝකේ. එහෙම වචනයක් නැහැ. We have stress here in physics related to the elasticity. Okay. Elasticity. But not the stress you are referring. And there is no such thing. What we need to do, work hard and try to make sure, or try to win your goals. Stress that is a tensor. Okay, tensor it's like you need more dimensions, like not to one direction, you need several directions. Okay, මෙයාට වෙලා තියෙන හැමතැනටම වැඩ කරනවා. එහෙමනේ directions දෙකක් තියෙනවනේ. Let's take two directions. You need two directions, three directions. Likewise, then it's known as tensor. Okay, a property, single property, you need to describe. So speed degatto, you can use only one direction. Maybe north, maybe south, maybe left side, right side. But there are some properties you need to explain, like x direction and y direction. Yeah, like that. So then it's known as tensor. ඒක නමතර දෙයක් මං කිව්වේ හරිය ඒවා හිතන්න එපා. මම වැඩක් නැහැ නේ අපිට ඕනේ නැහැ. මම නිකන් මේ කියන්නේ. Okay, so tensor කියලා ෆිල්ම් එකක් තියෙනවනේ මොකක් හරි මතක නැහැ මට. එහෙම තියෙනවා වගේ. So pressure. Okay, so there are so many properties. I think in the tutor also there are properties. Yeah. මේක අදීශයකට තමයි ස්ට්‍රෙස් එක දාලා තියෙන්නේ. වැරදි හොඳේ. මේක ස්ට්‍රෙස් කියලා එකක් තියෙනවා මං හිතන්නේ. In the vector column there is a something known as stress. Remove that. Pressure hari stress කියන එක ලියන්න එපා. Stress is not a scale, is a vector. මම හිතන්නේ ඒගොල්ලන් ටියුට් එකේ තියෙනවා නම් කපා ගන්න. Stress is a tensor. Okay. ඕගොල්ලන් ටියුට් එකේ එහෙම තියෙනවා වගේ මම හිතන ඉන්න බලන්න ටියුට් එක. English medium one, සිංහල medium එකේ තියෙනවා. English medium one. Yes. Remove that term. Scale එක just write additional information. Additional stress is a tensor. Not scalar, not a vector. It's a higher level of vector. Higher level of vector. Stress කියන්නේ higher level of vector. I'll show you. ඒක ෆිසික්ස් වලට ඕනේ නැහැ. පරම සත්‍ය කියලා දෙන්න ගියාම මේ ඕනේ වෙන්නේ. හරි. Okay, stress is a tensor quantity. Yes, stress is a tensor quantity. Especially, it's a second rank tensor, which means it requires two directional specification to be fully defined. You need two directional specifications. So orientation of the surface plane and the direction of the force acting upon it. Okay. So y is not a vector, unlike standard vector, which only requires single magnitude and direction, one direction. Stress describes an internal state of force acting over an area because you can cut. So you can see Cauchy. This one is Cauchy stress. These are higher level of vector quantities. මේ වගේ දැක්කම බය හිතෙනවා ඔයගොල්ලෝ මේ. So in the A levels mathematics also still you are not learning these things, but you can learn this one in engineering or mathematics degree. Okay, ඒව දක්නේ අපිට. So we can write to that stress is a tensor quantity, especially this second rank tensor, which means it requires two directional specification. Alright. If you want, you can write stress is a tensor which needs two directional specifications. Okay. මම නිකන් කිව්වේ හරි ඒක දාගන්න එපා. It's not a scalar. High tense stress. Stress කියන එක ඕන වෙන්නේ that lesson is coming, that stress is coming in elasticity. Elasticity lesson. Stress is the same, like it's acting as pressure, but it's a different thing. Okay. මේ දෙකේ dimension සමානයි, pressure and the stress, but two different things. Okay, so that in your tube that one is there, so remove that one. I can show you the tube. I'll show you later. මම පෙන් එකට දාගත්තේ නැහැ. හරි, okay. So stress is not a vector either. stress is not a vector either. ඒ වගේ විභාගයට ඇහුවොත් ඔයා හිතන්න එක يعني in the level in the A level level if someone asks stress as a vector, no, you can consider it is a scalar, but actual one is tensor. මොකද ඒක directions දෙකක් තියෙනවානේ. Because of that you can consider it's not a vector, but it is a different term, tensor, but you can put that one as a scalar. Direction දෙකක් තියෙන හින්දා again you can categorize as a scalar. හරි කොහොමද pressure stress දෙකම එක වගේ. pressure වෙලා තියෙන්නේ there are not two directions, there are n number of I mean infinite directions. So then you can put that one in scalar. මේක directions ගොඩාක් තියෙනවා. හරි. So because of that one put can consider scalar. But in A level, yes. For A level terms එක ඇහුවොත් මං හිතන්නේ කවුරු tensor කියන එක දන්නවා කියලා. හරි. So when I'm doing A level, I also don't know about this one, tensor. Okay. For A level, consider stress as a scalar quantity. For A level, okay. But පරම සත්‍ය ඉගෙන ගන්න. පරම සත්‍ය ඉගෙන මේක කොහොමද දාගන්නේ? පරම සත්‍ය කියන එකක් තියෙනවා. But for some cases, you are not learning up to that level. So then you can consider stress also scalar like the pressure. Like the pressure. For A level. Because it doesn't have a one direction, there are two directions. So you can put into the scalar again because there are so many directions. Not so many, two. So vector, I'm giving interval at 10 p.m. No need to worry. අද දෙනවා අද නම් දෙනවා හැමදාම. Money classes වලට දෙනවා. So then vector, what is a vector? You know, you need to describe the magnitude and the direction both. So you can write force, velocity, displacement, not the distance, the displacement. Then I'm not going the same order. Order you can learn acceleration, momentum, then impulse, momentum, torque, or this one there's another synonym, what we call the moment of force. Torque and moment synonym, okay. Then angular velocity, angular acceleration, all these things are vector quantities. So when we are explaining these things separately, again you are learning this is a vector property. So let's say now we are learning acceleration in linear motion. So then you can learn acceleration is a vector. So in the corresponding lessons also we can identify that one is whether it is a vector or a scalar. So electric field intensity, magnetic flux density, gravitational acceleration. I'm just giving examples, set of examples. All result එනවද? එහෙනම් අපිට celebrate කරන්න පුළුවන්ද? 12ට කලින් එයිද? Okay. I'm not sure still. Let's see. Okay. Pray කරන්න දෙයක් නැහැ ඉතින් O level කියන්නේ. මොකක්ද නෑ කවන්නේ එච්චරොන්. Okay, I'm not criticizing, but that one doesn't matter, okay? So I'm not criticizing, but O level nowadays O level is not important, you know. A level somehow yes, it's important. Your future is depending on the A levels nowadays, not the O levels. So don't think about O levels. So I personally I got 9 A's, I know that, but you can have a certain what we call the happiness, yes, because you work so hard for that exam also, and finally you are getting the maximum, means the 9 A's, okay, but 8 A's, 7 A's, 6 A's, or whatever A's, doesn't matter. Hari. Um, okay, so yeah, there is no importance of that all levels nowadays, but yeah, sometimes for university application, they are checking your, I mean, English knowledge based on the A levels. Like, they need at least a B pass or C pass for English, oral English for some courses. Okay, and also for science or maths, they are expecting all level result for those degrees or only. ඔයගොල්ලෝ engineering medicine යන්න හිතන්න, then they are not checking all level result. Okay, and yeah, all level is good, but A level is far away, far ahead when you compare with the O levels. So work hard for A levels. අපිට අපි මම මුලින් ක්ලාස් ගිහපු දවසේ අපි A level කරද්දී අපි කිව්ව මැත්ස් ක්ලාස් එකේ අපිට කියන්නේ O level කියන්නේ ගොම් පාටයක් කියලා. හරි. එහෙමම තමයි කිව්වේ. මං ගිහපු ඒ සර්, මං කියේ මැත්ස් කරන සර් කෙනෙක්. හරි. මට නම්බර් කියන්නේ මනෝ සෝලංගරයි සර්. මං ගියේ මැත්ස් සර්. හරි. මං කියන්නේ O level කියන්නේ ගොම් පාටයක්. කොහොමද තමයි කියන්නේ. On the very first day that he is explaining, like O level is not that much important. Okay. Yeah. එහෙමයි. Now you work hard, but doesn't matter. It's not that important. Yes, I know, but you applied your maximum effort for that. හරි. දැන් මෙහෙමනේ. If you are applying your maximum effort for something, definitely you need to get a benefit. So let's take you are applying your maximum effort for a certain business. Then you need to take the benefits. You need to take the final what we call the profit. Otherwise, what it's useless ne? Time pass karna it's useless there. Right? So if you are applying whatever, I mean, sometimes you are paying for classes and you are applying your what we call the money as well as your effort. So how do you what is the final outcome for that effort, for that time, especially time එක ඔයගොල්ලන්ගේ wealth එක, or your money, and sometimes your effort, most important thing. So finally there should be a certain value addition for that. That one is the final result. So then it's okay. You are expecting 9 A's, 8 A's, whatever A's or whatever result, that one somehow pay the final, I mean, that one gives the final outcome. ඒකෙන් අන්තිමට ඔක්කොම තියෙන හිතේ සතුටනේ. හිතේ සතුට එන්නේ ඕකෙන් තමයි. හරි, final result. So yeah, definitely. So your parents, they are also expecting higher result from you, because finally they are also can happy with you. අන්තිමට සතුට වෙන එක නෝන, සතුට ගේන්න තමයි මහන්සි වෙන්නේ. හරි. කෙමිස්ට්‍රි වලට මම ගියේ ජීවක සී ප්‍රේමරාජ්, අහලා තියෙනවද? ජීවක සී ප්‍රේමරාජ් දැන් එයා වැඩි ක්ලාස් කරන්නේ නැහැ. හරි. Mano Solangari, so now he's doing again, I think, for 228 students in Nugegoda. He's the perfect one. Okay, I learned the maths A to Z from his method. ඒක සුපිරියක්. හරි, අපෝ බය වෙන්න දෙයක් නැහැ. හැබැයි මම දන්නේ මේ දවස්වල online එහෙම කොහොමද කරන්න කියලා, but he's perfect. Jeevak C. Premaraj, he's not doing now. I think Jeevak C. Premaraj, he has set of books and we refer those things. He's the number one chemistry teacher during my time. Jamila Selam, Anuradha Perera නැහැ. හරි. Tamil හේරජා සිං හිටියා. හරි, හිටියා ඒ දවස්වල හිටියා. Jeevaka C. Premaraj, he is the best chemistry teacher in Colombo district. He is doing bilingual class. Okay, bilingual means like English medium and Sinhala medium separate class, and MCQ paper, we had the MCQ paper discussion. That one is bilingual. So now you know that I am doing a quiz discussions also in bilingual. Likewise, explaining Sinhala and again English, Sinhala and English. ඒක මරු හොඳයි, මම හරි ආසයි, because those days I did in Sinhala medium also. I can single කරේ. එතකොට I prefer to hear the English terms also. අර සිංහලෙන් කරා ගුරු හොයාගන්න බෑනේ. එතකොට කමක් නැහැ. Just now you don't no need to do the Sinhala because you have in physics I'm covering the in English pure in I mean perfect English medium class. So no need to be afraid about that physics content. And chemistry and biology, maths actually maths you don't need the English medium, but the concept, if you know the concept, then you can manage the way to calculate it. Okay. But my chemistry sir, he is doing the bilingual class. He was doing the bilingual class. It's perfect. Okay. මම එකපාරක් සිංහල කියනවා අපේ ඉංග්‍රීසි කියනවා මරු. හරි ආසයි හංගින්. ඒ කාලේ මට හොඳ කෙමිස්ට්‍රි පුළුවන් ඉංග්‍රීසි දැන් බෑ. මතක නැහැ. Okay. English terms I know that. Okay. So හරි අපි physics කරේ පුසල්ල සර්ගේ හරි එයා සිංහලෙන් විතරනේ කරන්නේ. ඉතින් කමක් නැහැ. So you can join with us. Yeah. අපි යමු ඉස්සරහට වෙලා යන කතා කරන්නේ. මේ දවස්වල හොඳ maths වලට chemistry වලට probably I don't like to recommend like the Sinhala medium okay, but Sinhala medium teachers are okay, but එහෙම මම recommend කරනවා කියන්නේ මම recommend කියන්නේ not according to my perspective, because I don't have any physical connection with those teachers, but there are set of physical teachers and there are set of teachers doing chemistry like Geet sir කියලා සර් කෙනෙක් ඉන්නවා හොඳයි කියලා ළමයි කියනවා ළමයිගේ අයත් එක Geet කියලා සර් කෙනෙක් හරි he's doing sailing pen නුගේගොඩ and තව මම දන්න chemistry වලට කියන ළමයි කියන ඒවා හරිද තව කවුද English medium I'm talking about English medium lectures තව නිරන්දික ජයවර්ධන he's doing I mean in his method is also okay good කියලා අහලා තියෙනවා I don't know you can ask from your seniors some you can just participate whatever online course, and if it is suitable for your passion your method then follow that class. ඔයාට සෙට් වෙන්නේ නැත්නම් මම කොච්චර කිව්වත් හරියන්නේ නැහැ නේ. ඔයගොල්ලන්ට සෙට් වෙන්නේ නැත්තම් එහෙම තියෙනවා හරි. For bio I think Charita Singh is there for biology English medium. I don't know any other English medium. තව ඉන්නවා සෙට් මේක කියලා මම අර අපේ පොඩි කෙනෙක් මේ සේලින් පෙන් එකේ හොඳයි කියලා කියනවා. I don't know. ධනංජය හරි ඒගොල්ලොත් කරනවා මං හිතන්නේ පරණටදලා English medium. Maybe you can try, just go to the first class whatever online class or identify whether his method is okay or perfect for you. And for combined maths you can go to any Sinhala medium, doesn't matter. Haris Solangar is doing now I think in the gravity there is a student known as gravity Nugegod. Ruansa is okay, good. I went to the Ruansa's also. He's also perfect. Yeah, the methods are different, but that method is also suited for any student. Okay. Yeah. So Chinese හොඳයි කියලා කියනවා තමයි මම අහලා තියෙන I'm not recommending, I'm just saying what the students are telling me. Okay. එහෙම recommend කරන්න මට ඇත්තටම I don't have any physical connection with them and I don't know the way that they are teaching. Okay. ඔයගොල්ලෝ physics වලට තෝරන recommendations. Okay. No නේද? හරි physics වලට you can come for you can realize the difference between maths English medium class මං දන්නේ නැහැ අතට. There is no such maths English medium class. That's the problem. So yeah, but you can join with the Sinhala medium, but the explanations are in Sinhala, but you can realize the way to calculate the questions. Mandava sir he's doing maths English medium classes I think. Mandava sir is doing good I think, but එක එක දේවල් මං කියන්නේ සමහර එක එක දේවල් අහලා තියෙනවා, but okay he's okay කියලා හිතෙනවා මට. Mandapa Pandit, he's also another senior IR from my college and university. Okay, he's also doing I think Are you doing good? Mandam? Are you? Sir? Okay. එහෙම තේරෙනවද ඔයගොල්ලෝ ගිහින් බලන්න. මට දැන් මැත්ස් මතකත් නැහැ ඉච්චර කෙමිස්ට්‍රි නම් පොඩ්ඩක් මතක නැහැ. Okay මගෙන් කෙමිස්ට්‍රි හැම බෑ මට. I don't because I am only teaching the physics, so my teaching skills may be purely based on physics only. Okay, I can't explain the chemistry or maths now. Maths නම් ඉස්සර පුළුවන් දැන් ඒ කට්ටියක් අඩු වෙලා තියෙන්නේ. Okay. So I know the maths, I can calculate, I can solve the questions, but I can't teach. The teaching ability is not developed for that level. Okay, but I can teach the basic concepts starting from basic level to higher level, the physics. Okay. එහෙමනේ අපි develop වෙන්නේ mind එක. මම දැන් උගන්න අවුරුදු 5ක් උගන්න. හරි. I started this teaching. I developed my teaching style. I have been teaching from 2021. I did the ALOS 2019. After that, I joined for a certain institute as instructor. After that, with the corona, I started online classes, like individual and small group classes. Up to this March, I did only the small group classes and the individual classes near my area. My university, my first goal is to achieve my academics. Okay, so after that I started the mass classes. This one, your one is the first mass class. Okay, mass tour thamma lamai poddai, but okay, let's develop. Let's see after 2-3 years. හරි අපි කතා කරමු මේක ඉවර කරලා පොඩ්ඩක් මැද්දේදී නැත්නම් එක දිගට කතා කරාම හරි okay. I'll explain the way that you are studying later. Let's move to the lesson again. නැත්නම් මේක ඉවර කරන්න බැරි වෙනවා. Okay, scalar and the vector. So now you have two terms, scalar and the vector, and we have another term as tensor, but for A level you can consider stress is also scalar. Okay, then let's move to the representations. So if you want to represent the temperature, that is a scale quantity, then you can represent that one using a number. Temperature 20 degrees Celsius. You need to represent the number with the correct unit. If you indicate Kelvin, that is a different idea, different measurement, different size. Okay, so likewise you can represent the number with the correct unit to represent the what we call the scale quantity. මට දැන් scale quantity පොතේ ලියන්න ඕන. I need to represent the scale quantity on your book. So then I need a representation. I need a certain representation. So if you want to represent time, then 2 seconds. 1 hour, 3 minutes. Likewise, I can represent only the number with the correct unit. Unit gives the size. So 2 seconds is very small, you feel it. 1 hour, you can feel it. If you take 10 days, you can feel the size of the, you can feel that size with the unit and the number. You need to represent the correct unit as, with the number. But how do we represent the vector? We need to develop a certain way to represent a vector. කොහොමද පොතේ vector එකක් represent කරන්නේ? That's the problem. Okay, so now just write this one. එහෙම ලියමු අපි. Okay, so නිකන් මෙහෙම දාගන්න යම් පොඩි point එකක්. We can write something like this. A scalar can be represented using a numerical value, using a numerical value with the correct unit. a scalar quantity can be represented using a numerical value with the correct unit. Okay, but when we represent a vector, but to represent a vector, but to represent a vector, but to represent a vector, we need to define a certain specific method. We need to define a specific method to define a specific method to represent its to represent its to represent its comma to represent its comma. We need to define a special method to represent its comma. Magnitude, direction, third one, sense of direction. That is another part of the direction, but we can specifically mention that sense of direction. I'll explain. To represent its magnitude, direction, sense of direction. Sense of direction. Magnitude, direction, sense, and the sense of direction. We need to define a special method to represent its magnitude, direction, and the sense of direction. සිංහලෙන් කියන්නේ අභිදිශාව. Sense of direction. For that, we are using a geometrical representation of vector. So for that, we can use a geometrical representation. We are developing a special method, and that method is known as geometrical representation of a vector. Okay. So I'll explain what is the sense of direction with that example. So just identify this one. So now let's take there is a box. I am applying a force to be so let I am applying a force 5 Newton. 5 Newton. I am applying a force 5 Newton. Okay. So what is the magnitude? 5. What is the direction? Horizontal. Horizontal. The direction is horizontal. Here vertical. This is also vertical. This is horizontal. පොඩි අවුලක් තියෙන horizontal කිව්වම this is horizontal, this is also horizontal. Vertical, vertical. මොකද්ද sense of direction කියන්නේ එහෙනම්? Horizontally right side, horizontally left side, vertically upward, vertically downward. That upward downward term is the sense of direction. Okay, so remember the concept. So this arrowhead can be represented. I mean, when you represent the vector, you normally we are representing that one using the arrowhead. Okay, so this is horizontal, horizontal, vertical, vertical. Remember the concept. Okay, so now just write the heading. I'll give that one later. Later means with the definition method. So write down the heading: geometrical. Geometrical vector representation. Vector representation geometrical representation of vector. Right or left can පුළුවන්, yes, but horizontally is the direction. The right and left you can consider like in 2D environment. 2D environment, then 2D. This someone can define this one as right. Hi. Then okay, so let's take this line. Hi. Then someone can define this is right and this is left. තව කහරට කියන්න පුළුවන් this is east, this is west. හරිද? So but someone can define අපි තව මිනිස්සෙක් මෙහෙම ඉන්නකොට හරි okay, but let's take now that person locates along this direction. උඩින් බලන රූපයක් හරි උඩින් බලන එක. Take the plan view. Right? This is the location of that person. This is east, this is west, this is north, this is south. So someone can define this one is left and this is right. But here this is north and this is left, this is right again. That depends on your orientation. Like after heightum කියන්න බෑනේ. හරි. Yeah, normally left and right there is no exact meaning. So but if you take horizontal, vertical, or with a 30 degree or 90 degree with the 180, so you can consider this is 90 degree. 90 degree to which direction? North or south? So 90 degree is the direction, 90 degree is the direction, then 90 degree upward or northern, or 90 degree downward, south. So likewise this is the sense of direction with the direction is 90. Okay, so horizontal means again I'm taking the horizontal is this direction. That horizontal is also not good. Horizontal simply you can represent horizontal based on your diagram. Horizontal diagram, but in actual world there is no such thing horizontal. Horizontal is not a direction. But horizontal can I can represent this is horizontal, this is horizontal, this is horizontal, this is also horizontal. There is no such exact direction. Then I can write දෙනවා මේ කියන එක ඔක්කොම horizontal මේ ඔක්කොම horizontal හරිද ඔක්කොම horizontal. So horizontal, but horizontally which direction? Now northern, left or right is also not exactly gives the idea. You need to explain to which direction. Direction and the correct what we called 90 degree to upward, north, or likewise. Okay, so that's why we need the direction and the sense of direction both. Representation of on did you get the concept? No need to get confused. If you represent a 90 degree or 180, those are the direction. 0 degree angle or horizontal, vertical, but you need to represent vertically upward or downwards. 30 degree along the plane, or let's see along 30 degree, let's say there is a plane here. There is an inclined plane. Okay, so with the 30 degree angle, inclined plane. So it's along the plane or moving down along the plane upwards or along the plane downwards. So likewise, you need to represent the sense of direction also. Okay. Now vector representation. So how do you represent a vector now? How do you represent a vector now? So let's draw something like this. Okay, so this is my actual system of force. This is my actual, I'm taking a vector, force is a vector. So I'm taking a force. This is my actual system. So I'm applying a force. So I'm marking a 5 Newton force with a 30 degree angle. 30 degree angle, this is the direction. And you can identify the sense of direction also in this diagram. This is the actual vector. So I need to represent this one on your book. How do you do that? Okay, so we can represent this vector. We can represent this vector using a line. Okay, the line length equals or directly proportional to the magnitude of the vector. So let's take, so you need to use a certain scale for that. Proportional means simply 1 centimeter can be represent 1 Newton, or you can use whatever. Let's take this one is 10 Newton. 10 කියලා ගමු ලේසියට. Let's say this is 10 Newton, then you can use 2 centimeter represent 1 Newton. You can use whatever proportionality. You know, you can use a scale. Use a scale like this, and you can draw a line. You can draw a line. So let's take this is 10 Newton. I'm selecting 2 centimeter a certain proportionality. Okay, so I can represent that. Here I'm using scale. 1 centimeter represent 2 Newton. I can use 1 centimeter is using, I'm using 1 centimeter to indicate 2 Newton. Okay, so then I can draw a line. I can draw a line which is equal to 5 centimeter, because this magnitude is 10. I can use a 5 centimeter long what we called um, a line. Okay, so then you need to represent the direction correctly. So that one is inclined to the horizontal with the 30 degree. So I can draw a line. That line length should be 5 centimeter. Okay, you can draw this one with me. This is the line 5 centimeter. If you want, you can take your ruler and measure it. Doesn't matter. So I am selecting a horizontal direction also, because this angle I need to mark the angle. So this is 30 degree. So here this is the actual vector, actual set of forces. So I can represent that one on your book using a line, and the line length I'm selecting 5 centimeter. I'm selecting 5 centimeter. Why? Because I'm selecting scale. I'm selecting an scale which is which is directly proportional to the or simply I'm selecting a scale. 1 centimeter provides 2 Newton. Then I can draw a line which is equal to 5 centimeter. Then this one gives 10 Newton. So length can be used to represent the magnitude, and the direction can be used to the direction of the or angle. Here I mark is the direction, give the direction. And the sense of direction, you know, there is a sense of direction. So that one again we can draw using an arrowhead. Okay, so this is the vector representation. So normally we can use the terminal point. We can mark the terminal point use the capital English letters. You can mark the, so now this is AB vector. So for that we are using the capital English letters to represent the ends or the terminals. Okay. ඊට කලින් මං කියපේකද? So මං කියන්නම්කෝ එකපාරක්. Hi, other students can write down this one. So before the geometry representation, I said that a scalar මං හරිම වචන නැති වෙන්න පුළුවන්. The idea, the scalar scalar can be represented using a numerical value with the correct unit, but to represent a vector we need a special method which represent its magnitude, direction, sense of direction. To represent a vector, so other students can note down this one. You can represent this one, you can mark this one. So the previous, before this point I told you why we need a method. So for a scale we can represent the scale using a numerical value with the correct unit, but a vector, to represent a vector we need a special method to represent its magnitude, direction, and the sense of direction. We need a special method to represent a vector. We need a special arrangement or method to represent vector to represent its magnitude, direction, and the sense of direction. Okay, so our goal is geometrical representation of vector. Hi. So length of the line. So simply we can represent. Hi. So a vector can be marked or represent on the book using a simple line, which the length which the magnitude is represented by the length by the length of the line by the length of the line. For that we can use certain proportionality make a scale. But if you want to draw this one in real world, then you need to take a scale. So we are doing certain vector diagrams, then you need to draw the actual ones. So then you need to use correct scale. The magnitude can be represented as a certain proportional with a certain proportionality. Proportionality this one you can see 1 centimeter 2, then 5 centimeter is representing 10. Use a correct scale for that. Then the direction with the same angle. Here, how do we represent direction with the same angle? Okay, and the sense of direction using the arrowhead. So this is known as sense of direction. Huh? So if you want to mark that one, this is the direction. This 30 degree is the direction. 30 degree is the direction. This is the sense of direction. Here also in the actual world you are applying arrowhead. This one is the sense of direction. This is the magnitude. These are the three properties in the vector. But there are some other properties, line of action. This one is the line of action. එකද මං කියන්න ඒ ක්‍රියාත්මක කරන රේඛාව. හරි. So this is the line of action. This is the line of action where your vector is acting on. This is the point of action. This is the point where the vector is acting, but this one known as line of action. එයා ක්‍රියාත්මක කරන රේඛාව. The vector is acting on this line. In the actual world, you need these properties to describe it, describe the vector in the actual world. Line of action. Or it is not one to describe a vector. මොකද්ද? Magnitude, direction, sense of direction, and the line of action. Line of action means the extended line of it. Just the extended line of it. Those are the properties or characteristics you need to represent or explain a vector, actual vector. Line of action. මතක තියාගන්න හරි. These are the properties of the actual vector. But line of action කියලා ලොකු දෙයක් නෙමෙයි. ඕන වෙනවා ඉස්සරහට. You need that term. Direction, sense of direction, magnitude, the line of action. So vector representation, we can mark that vector. No need to think about the line of action. ඒක වැඩක් නැහැ. You can mark that vector here. But you need that line of action. We will do that one with the mechanics, okay? ඒක අපි ඉස්සරහට කතා කරමු බය වෙන්න එපා. So these are the properties. These parts are the 4 important properties of parameters you need to represent a vector. So between these, among those, we can represent these green color ones. We can represent those green color ones through this vector representation. Line of action එක අඳින්න බෑ අපි පෙන්වන්න ඕනේ කියන්නේ කක් හරි. Let's take, you can't show that one in the vector diagram. Okay, again හිතන්න එපා. Line of action, you can't show that one in the vector diagram. Can, අපි ඉස්සරහට ගිහින් ගමු. No need to worry. Hi. No need to use a protector. So this is sense of direction. Arrowhead එක පල්ලෙහාට කියන එක. I'll mark. So no need to use a protector. එහෙම ඕනේ නැහැ. Just mark that 30. නිකන් angle එක mark කරලා 30 කියලා දාලා. කවුරුත් බලන්නේ නැහැ නේ. ඕවනේ බලන්න. අනාගතයේදී කාට හරි note එක එහෙම ඕනේ නැහැ. You can do the you are the one referring the note නේ. නැත්නම් මම කාට හරි දෙන්න ලියලා දෙන්න note එක ලියලා දෙනවා. හරි. යාළුවෙක් ඉන්නවා special යාළුවෙක්. I need to write the note perfectly and give it to that person. එහෙමනම් ඉතින් කමක් නැහැ. හරි. Just write because you are the one referring this one. Sense of the direction. I know that actually there are some students, they are willing to write a perfect note and provide it to the other students. එහෙම හොඳ වැඩ හරි. හොඳ වැඩ. මම දන්නවා එහෙම personally මම දන්නවා. There are students like they are writing a perfect note, they are clean and nice note and then providing to the groups නේ Telegram group වල දානවා. හොඳයිනේ. දැන් අනිත් කෙනාට බැරි කෙනෙක්ම ඉගෙන ගන්නවා. එහෙම අනිත් පුළුවන් හැම වෙලාවෙම උදව් කරන්න. If you get chance to help others, always try to help, because somehow those things are again coming in whatever way, we don't know the way, but somehow they are helping for your success. So sense of direction using arrowhead. So magnetic can be represented as the length of the line, but we need to use a certain proportionality, scale, and the direction with the same angle, sense of direction with the arrowhead. So this is sense of direction. We can represent that one using arrowhead here. Here also arrow එකක් තමයි තියෙන්නේ, yes, but we can represent that one using arrowhead on the vector diagram also. This is vector representation. Okay. නෑ ටියුට් එක හිතන්න එපා හරි. The direction is this angle, arrowhead is the sense of direction. Don't follow the tute. Yeah, that's okay. The arrowhead gives the direction, but arrowhead is gives the sense of direction. මම ඔක මේ සමහර දේවල් වෙනස් කරා but මටත් මිස් වෙන්නේ නැති. So refer my note. I'm giving you a note, so you refer that one. I changed certain things in the tute. I changed the order actually. I didn't, but I'm not. I didn't change that. I didn't provide that one to you because then there might be certain problems with the Anuradha's class. ඒක English medium කරන කට්ටිය ඉන්නවනේ තාම සිංහල ඉගෙන ගන්න කට්ටිය. English medium කරනවා but they are learning in Sinhala. So then there is a certain problem with that order if I change the order. Okay, doesn't matter. I'm giving I'm providing a note on the board, so write that one. Always try to write that one, especially for mechanics. Arrowhead gives a sense of direction. This angle provides the direction, and the length provides the magnitude. ඔච්චරයි. හරි lazy. කටපාඩම් කරන දෙයක් නෙමෙයි මම කියන්නේ. හරි. The length of the line is the magnitude. This angle is the same angle here. So that is the direction, and this is the sense of direction. Okay. හරිද? ඉක්මනට කරමු ටිකක් වේගය වැඩි කරන්න ඕන. හරි දැන් අපි ටික ටික we need to increase the speed also. Okay, so this is the box. This is a physical box. We are applying 10 Newton. This is a line of action of that 10 Newton. This third degree, we can mark the horizontal. This is horizontal. If it is horizontal, this is horizontal force. Right? So you can have horizontally the direction. And this arrowhead gives the sense of direction. Right? Those are equal in the both. Here also a vector representation. Board again. This is also vector representation. The length of this one is the so here when I'm marking this actual vector, again I'm marking that one on the book. Similar properties here in the actual vectors you can see the same angle. The direction you need to be the same angle. The sense of direction I can mark with the arrowhead. At the environment arrow at the local you can't see arrow, but here to represent that actual vector I need arrow in this diagram also. At the local වහනයක් යනවා මේ පැත්තට, then you can't see arrow with that vehicle. පේනවා දැන් ඉතලා කොහොම ගහලා තියෙනවා උඩින් යනවා පේන්නේ නැහනේ. So likewise you can't see the actual arrow in that. You can't see an arrow with the actual environment, but now when you mark that one here you can mark arrowhead. That's the concept. Okay, තේරෙනවද මේක? So and important thing is normally we are using capital letters to represent the corner endings. හරි දැන් මේක හරියද? අගොඩ මේක කැතයි වුණා හින්දා I'll draw another diagram again. So I'll move forward. හරිනේ. So if you are writing still then please raise your hand. ඉක්මනට යමු. Okay. So this is a vector representation. I'll draw another vector representation again. I'll take another example. So now let's take there is a moving object. That object moves to which direction? This is also another way to, I mean, I'm also marking the actual environment, actual property, actual vector. So let's take there's a vehicle. Then to represent direction again you need to use the arrowhead thing. වෙන කරන්න දෙයක් නැහැ. මට නැත්නම් ඔයගොල්ලෝ පේනවනේ විදියක් නැහැ ඒක. So let's take there is a moving vehicle 20 meters per second. හරි. To this direction. So now we can represent a vector. You can represent a vector and its line. And its line you can mark with AB or CD, whatever, capital letters PQ, capital letters, and direction is horizontal. Here you can see direction is horizontal. It's moving to the horizontal direction. So on the road, I mean, horizontal. So you can use the horizontal. Horizontal to which direction? Right side. The direction is horizontal. Another example. Sense of direction, right side. Sense of direction is a part of direction. Direction appear on sense of direction. is a part of direction actually. Is right. So that is the, and the magnitude is 20. So then we can represent all these things using a vector representation, a line, then it's a horizontal, so it's a horizontal line then direction using arrowhead. Okay. So the length, so normally we have certain mathematical ways to represent a vector, a symbolic expression now. Okay. So here we can write, so this is the velocity. This is the velocity. So I would like to mark that on your book. So then this is the way to mark it. Okay. So the length of this one is representing 20. No need to use a scale now. Whatever scale, using whatever scale, this one is proportional. The length is proportional to the 20. This length, whatever scale. So no need to measure 1 centimeter like that, or 2 centimeter. Using whatever scale, proportional scale, we can represent the length of this one as equal to 20. If you mark that on your book, you can just write the length of this one is 20. But correct, I mean, if you want the actual vector diagram, then yes. You need to use the scale. But for day-to-day works, if you want to mark the vector, just draw a line, horizontal line, and mark the sense of direction also. And after that, just mark the length as 20. Length as 20. Okay. There is a whatever scale, maybe 1.5 centimeter gives 1 Newton, maybe 1.321 you provide using whatever scale, I don't know, no need, provide 1 Newton. Again හිතන්න ඕනේ නැහැ. හරි මොකක් හරි scale එකකින් තියෙනවා. So we simply you can write the length is proportional. The length of the line proportional to the magnitude. හරි දාගන්නකො. You can see the direction horizontal, sense of direction right side, magnitude is proportional to the, I mean length is proportional to the magnitude. You are the first batch I'm conducting as my professional career. So in my professional career, you are the first batch, so I need a good result from you. I'm also working hard. We'll do some additional things, additional discussion, question discussion, especially for English medium. So I need, since you are the one joining from the beginning, I need all of you having higher result, like just not C, S, A. I need all A for physics. A, B shape, A තමයි ලස්සන හරි. A for physics, not actually A, 3 A's. I can 3 A's ගන්න මහන්සි වෙන්න ඕන හරි. Not that much easy, but we'll work for that. ඔයගොල්ලෝ මට ඒක අරන එක තමයි මට දෙන්න පුළුවන් එකම from my side I will definitely work for that, and from your side also you need to support. දෙන්න පුළුවන් ලොකුම දේ තමයි ඒ තුනක් අරන් පෙන්නන්න. Physics වලට especially for physics you need to get a A. But I like to have a 3 A's from your side, because then that is the final ultimate happiness for us, satisfaction. ඇතට ඕක රිසල්ට් එක අපිට සතුටු වෙන්න පුළුවන්. නැත්නම් මට දැනගත්තෙන් මගේ රිසල්ට් එක. හරි. දැන් මට ඇත්තටම මම සතුටු වෙන්නේ මගේ රිසල්ට් එක. I can be proud of about myself with my result. But with your result, I can get a satisfaction, not a proud, because I'm just guiding you. You are the one who is following them. You are the one who are following, who are following. I මට ඔයගොල්ලෝ ගැන proud එකක් එන්න පුළුවන්, but එහෙම නෙවෙයි මම කියන්නේ. So I can get a certain self satisfaction. Okay, I somehow contribute for your future, your success. එහෙම කියලා. හරිද? ඔයගොල්ලෝ එකට contribute කරන්න. You can contribute. හරි, තව කෙනෙක් සතුටු කරලා නෑ කොච්චර හොඳ දෙයක්ද නේ. Okay, so now get the idea. We have a moving vehicle, moving car. So the direction is horizontal, sensor direction is right side, magnitude is 20. So I can mark that one on a straight on a book using a line. The line length is proportional to the magnitude. No need to use a scale, just write whatever line, horizontal line, because this is horizontal, then horizontal line. The length, no need to measure. Somehow this one proportional to the magnitude 20. Okay, so this is the way that we are representing the vector. But how do we name it? So vector එක දැන් මේ දැන්තර පස්සේ දැන් මම පොතේ ඉරි කැල්ලක් ගහනවා. So you are drawing a line. After that we need to name that form for the, I mean we need to have a naming. නමක් නම් කරන්න එපා. හරි. For the naming we can use English capital letters, like here and here I use English capital letters. පොතේ ඇන්දර පස්සේ ඒක නමක් ගමන් තියෙන්න එපා. ගමක් ඕනේ at least a නමක්. A name. Okay, we need to represent a name. I mean we need to give a name for that, otherwise yeah. Okay, so now you can name it using English alphabet letters, or we can use simple letters. I'll tell you. So let's take another example. Let's take another example. So here I have a vector with a theta angle. Its magnitude is a, simple a. Let's take a vector. Let take a vector having the magnitude a. Just try to consider a vector. Consider a vector, not the vector anyway, a vector as follows. Okay, so I'm considering a vector. I would like to name a vector. I would like to give an example with the symbol. So magnitude a. The magnitude is a, direction is theta, this is sense of direction, this is the actual vector. So let's say there is a point mass, there is a force acting on that point mass. හරි, මම object එකක් උඩට මම force එකක් apply කරලා. එහෙම point mass එක. We are applying a force. හරි. එහෙම ඕනේ නැහැ නිකන් දාගන්න. හරි. So we are applying a vector on a point mass. Point mass කියන්නේ ලක්ෂීය ස්කන්ධය. So this is the actual vector. So I can represent this actual vector in this way using a line. The length of that line proportional to the magnitude. Okay, so with the correct same direction and the sense of direction. Okay, so I can represent vector AB. So I can use for the naming, we can use English alphabet letters. හරි, සිංහල අකුරු දාන්නේ නැහැ. සිංහල කරන කට්ටිය ඉංග්‍රීසි අකුරු තමයි දාන්නේ. අයන්න එහෙම දාන්නේ නැහැ. හරි, සිංහල මීඩියම් කරනත් ඉංග්‍රීසි alphabet letters තමයි දාන්නේ. බලන්න. නැත්තම් අයන්න එහෙම දාන්නේ. Okay, for the naming The English alphabet letters can be used. Capital letters. The English can. English can. English capital or block letters are using whatever one. I use here AB. If you put XY, PQ, EF, English letters are using. So then this one is known as vector AB. එතකොට පොඩි මෙහෙම දෙයක් තියෙනවා අපිට you need to represent after you name නමක් දෙනවනේ නමක් දුන්නට you need to explain the way to pronounce දැන් සමහර කට්ටිය you know that in Sinhala we can pronounce that one from right left to right. English also we are reading from left to right. And when you take Chinese, Arabic, you know, if you use Arabic, then it is right to left. If you take Chinese, it's Chinese the Korean. Korean, I think, is same right to left. Sorry, left to right, left to right. Chinese, I think, top to bottom. Chinese කියලා වචනයක් නැහැ. හරි Mandarin. I think that one is top to bottom. මම වැරදිද දන්නේ නැහැ. මොකක් හරි තුන එකක් තියෙනවා Japanese or Chinese or Korean. Out of these three, there is a language they are using top to bottom. You know? දන්නවා ඉතින් ඔයගොල්ලෝ බලනවනේ කතා හැම. මමත් බලනවා මට මතක නැහැ. මොකක්ද කියලා හරියට. හරි. වෙලාවක් නැහැ බලන්න මම බලන්නේ නැහැ. කීඩරාමයක් බලන්න ගත්තතර. නවත්ත ගන්න බෑ. සීන් එකක් තියෙනවා. හරි. ඉස්සරහින් බලන ඉඳලා හිටලා. හරි. හොඳ කියන්නේ හොඳ දෙයක් තියෙනවා නම් බලන්න. ඉගෙන ගන්න පුළුවන් දෙයක් තියෙනවා. අනිත් කියන්නේ සමහර ඒවා තියෙනවනේ it's like YouTube එකේ තියෙන බලන්න ඩවුන්ලෝඩ් කරලා බලන්න නැහැ. එහෙම ආසාවක් නැහැ. Okay. But the problem is you don't need to. I mean, if you get a free time, you can watch well. I mean, certain like documentary or a film doesn't matter. But if you want to learn from these things, try to watch some realistic one. Science fiction or like there are certain movies like science fictions or documentaries or simply whatever thing you need to learn from those. නිකම් බලලා ඔහේ මත් නෙමෙයි අර ඉගෙන ගන්න පුළුවන් දෙයක් ජීවිතේට හරි. එහෙම කතා තියෙනවා. If you try to watch a TV series like K-drama, then you know there are several episodes. So after watching one, then it's very hard to wait for the next one. Then we are watching the next one also if you have this all the episodes, and then it's very hard to stay neither without watching the second, third, fourth. Then you are expending total time for that. So what I did, ඔයගොල්ලෝ හොවන්නේ කොහොමද අපි ඒක කරන්නේ those things. මම games ගන්නවා. හරි ඉස්සර දැන් නම් ඒක ගහන්නේ. Games play කරනවා COD mobile. So what I did, if not in A levels කාලේ ෆෝන් තිබ්බේ නැහැ. හරි තිබ්බට ඔච්චර දෙයක් කරන්න යන්න තිබ්බේ නැහැ. COD mobile or what we call TV. So in those era we didn't have that kind of technology. YouTube තියන්නේ නැහැ. හරි මොකද YouTube වල data කැපෙනවා හරිද? data හරි ගණන්. හරි මම මේ කියන්නේ 2019 2018 those era. Okay, so then I didn't have I didn't do those stuff. WhatsApp use කරේ නැහැ එච්චර. Groups උත් නැහැ හරි. ඔය තියෙන Telegram WhatsApp group එහෙම ඒවා නැහැ. Okay, so then it's very easy to what we call work. I mean, not need to isolate, but to concentrate. It's very easy. But with the technology, you can use the AI or whatever YouTube videos to learn. And everything positive path. But now you have those facilities, so use that one in the certain positive way. Take the advantage from there. අපේ කාලේ තිබ්බේ නැහැ කියලා ඔයගොල්ලෝ මම හොයට කරන්න එපා කියන්නේ නැහැ. Use so we are using those stuff now for the university and other education. Then මට ඒක නවත්ත ගන්න බැරි නම් if you can't stop that kind of thing, then what we can do, if you want to watch, I mean let's say now you are somehow the YouTube එකේ හරි මොකක් හරි suggest කරනවා reel එකක් or story එකක්. Kirino podi video podi kala, then with that you need to watch, you like to watch this total episode balan hitena, then you are starting. After that it's very hard to I'm stay without watching the second episode. Home balan hitena okkoma. So how do you avoid that? Watch the last episode. Watch the last episode. එතකොට ඒක හරි. එතකොට බලන්න හිතෙන්නේ නැහැ මැද ඒවා. You know what's happening at the end. හරිද? ඒතර අපි කරන්නේ හොඳම දේ තමයි go for the last episode. හරිද? එතකොට හරි. එතකොට කිසි ප්‍රශ්නයක් නැහැ. You know what's happening at the end. So then your interest will be vanished. ඒක තමයි හරිම ලේසිදී if you want to avoid. හරි. දැන් බයින්න එපා මට. ඒක හරි අසාධාරණයි කියලා. Okay. So that's the way to avoid those stuff. You can watch the last episode, then you know what's happening at the end of the movie. Then you can concentrate for the physics and other stuff. And if you are want to play games or mobile phone games, delete the game. එතකොට අත යන්නේ නැහැ. හරි, delete the game. So what I did, I delete the game. මේක හරියන්නේ නැහැ, වෙලාව පත යනවා. ඔයාලට තේරෙනවා හරි කෙලවෙනවා කියලා තේරෙනවා තැනකදී. Then delete it if you can't manage. Delete the game or delete that app. Okay, TikTok app delete kar dem. That's the final solution. It's very easy. Okay. Okay. මං anime බලලා නැහැ. හරි. මම බලලා නැහැ. I don't know about the anime and other stuff. මම බලලා නැහැ ඒක. හරි. Okay. So if you want to watch any TV series, don't do that one nowadays because now you have other priorities. So for after doing A-levels, you have a one year, approximately yes, 1 year time, a free time. So then you can do whatever you want during that free time. A free time you want that come because finally you finish the A-levels and your academics A-levels are not started yet. That one is entirely free. But after getting to the university, definitely you need to work hard again. ඒකේ වැඩ කරනකම් කෙල වෙලා යනවා. බැච් මිස් වෙලා රිපීට් වෙවි ඉන්න පුළුවන්. හරි. එහෙම ඉන්න එපානේ. මෙච්චර මහන්සිලා එළවලු ඉගෙනගෙන. Okay. So my concept is you have a 1 free year time to do whatever you want, whatever things you can start during that 1 year gap between the A level, after the A levels and the before starting the academics. Okay. I mean university stuff, higher education. ඒකෙදී ඕන දෙයක් ආස දේවල් කරන්න. ජීවිතේ ආස දේවල් තියෙනවනේ කරන්න මිනිස්සුෙකුට. ඒවා ඒ කාලෙදී අවුරුද්දක් ඇති. You can do whatever you want within that time. Okay. So I'm හරි කමන්නේ. So you know that I think you can mark this one. So for naming, English capital letters are using are used කියනවා හරිනේ. Are used. Okay. So now the goal is how do you represent it? Using English capital letters, ne? Are used. So then we can represent this one. Okay, using capital letters AB. Vector AB. මම දැන් කිව්වේ කතන්දරේ යනවනේ අහකට හරිද? I just want to explain the direction. හරි. So the way to pronounce it. I told you we need to indicate the way to pronounce it. So in Sinhala we use the ref to write. In as I saw a message, Japanese. You are using top to bottom. Likewise, you are using a certain weight. I mean, you need to know the direction to pronounce it. So this one you can represent the direction to pronounce vector AB. A ඉඳන් B ට තමයි මේක තියෙන්නේ. That's the idea about this arrow. This arrow gives the direction of the vector. It's starting from A to B. A තමයි ඉස්සරහින් ඉන්නේ. A වලින් ඉඳන් B ට තමයි තියෙන්නේ. If you mark in this way, vector BA, that means the direction is B to A. B ඉඳන් A ට තියෙන්නේ. අපි මෙහෙම මාක් කරන්න පුළුවන්. ඒක ඉතින් කැතයි. හරි. Can same. Then vector B to A. Then you need to represent from B to A. B ඉඳන් A ට තියෙන්නේ. This one also okay. හරි. So this arrowhead gives the way to pronounce it. This is not AB, then this is BA. B ඉඳන් A ට කියවන්න. Hi, here also the representation is B to A, but normal standard is we are always using in this way A to B, Right? B to A. Likewise, so this is the way that we name it. Okay, vector AB, A to B. Hari. So let's take a break. So let's take a break. So it's 10:1. You can come after 10:11. I'll play a video and I can put moral up in. So after that video, you can join to the class. Okay, take a 10 minutes break at Adelaide. Okay, so you can complete the note. Okay, and I'll play a video. You can take an interval, 10 minutes break. Okay, then. Okay, let's start. Yes. Okay. Harid. Now let's start the after the break. Okay, intermission. Hi, tag dalam 12 වෙනකන් එනවා කොහොම. So consider vector and this is the actual vector, and now I can represent this one as a, this is a name. This is the name of this one. So or else there is another way to name this. There is another way to name this symbolic expression. If you use a magnitude like 20, then you are not doing that one for 20. හරි දැන් ඔය කට්ටිය ලෑස්තිද? දැන් පොඩ්ඩක් ඉන්ටර්ලෙන් පස්සේ මයින්ඩ් එක අපෝ ගන්න. හරිද? පොඩ්ඩක් අත්පය දිගාලා වතුර හැම බොන්න හොඳට. Always try to drink water. Keep the water bottle and drink it. Then you can get a certain refreshment. And දිමතන මේ රැයක් මහා රැය කරද්දී නේ. Okay. Those things are there, you know, but try to take a snap before attending to the class. පොඩ්ඩක් නිදාගෙන හැම එන්න. එතකොට ආතල් එක ඉගෙන ගන්න ඕන. වතුර බොන්න. තේ එකක් එහෙම රැට එහෙම කන්න ඕන නම් එහෙම කාලා බීලා එන්න. You can take that 10-minute break. Right? Yeah. Or while you are writing, while you are listening, take some spoon and eat it. Right? ආතල් එකේ කරන්න ආසාවෙන් කරන්න. ආසාවෙන් ඉගෙන ගන්න. Okay, for the naming, English capital letters are used, or we have another way. As a symbolic expression, if you know the length, if you use the length of this one as a, okay, so we know the length of this one is a. We know the length of this one as a. So because of that, we can, normally we can represent this simple letters for the length. Simple letters for the length. You can use vector a. They make cutting කියද්දි මේක AB නෙමෙයි හොඳේ. This one is not AB. This is vector AB. When you pronounce, this is vector AB. This is not just a curly එකක් දාන්න curly එකක්. This is sometimes in the books they mark in this way also. Doesn't matter. You can use this kind of curly below the letter or above the letter. Okay. So this one also another way to represent a vector property. This is just a way that simple a is not a length, it's not a scalar, this is a vector. Like this gravitational field intensity, gravitational acceleration, that is a vector. So g we can put a curly term there, curly sign to indicate that one is a vector. Okay, to represent this is not just a scalar, this is a vector. Another way to name it. Okay, so we can name according to the length, magnitude. We can write as a symbolic expression vector a. Vector a. Vector a. Okay, so write down that one, a symbolic expression to represent a vector. So this one is pronounced as vector AB, not just AB. This is vector simple a. So if you want to represent gravitational field intensity, we can use vector G. Magnetic field intensity vector. If you use capital letters, then you can use this arrow, not arrow actually, this marking to represent vector B. Vector B means magnetic flux density. To represent that property is a vector. I mean, let's say now we have electric field intensity. That's a vector property. So electric field intensity symbol is E. So that E we are using for energy also. Then there's the confusion. And because of that, we can write this is not the energy, this is electric field intensity. So I can include a symbol. This is symbolic, just symbol. This is a vector property. Vector E means electric field intensity. These are just naming. Nam karnidi. Hare. Keke nam teenon. Now this one, like a property. This property is a vector. This gravitation field intensity is a vector. If you use capital letters, always you are using a arrow above the symbol. If you use simple letters like gravitation field intensity is a vector, then we can put G here. So to indicate the real world the real world vectors, to indicate the real world vectors, or sometimes we are adding these symbols. The real world vectors මේක තන්දරේ නෙමෙයි හරි. So we learn that, but let you know velocity. So velocity, we can put capital V, velocity. This is the vector. Velocity is a vector, but because sometimes we use the V for volume, then this is volume, this is velocity. You can differentiate. Hi. Then okay. Likewise, you can differentiate, or you can identify separately when you, if you want to represent whatever property. Hi. Vector property you can use as, if it's a capital letter arrow above that one, is simple letter below the or above, whatever, doesn't matter. Okay. So, but here we can name this one using a capital AB or simple A. Hi. Now, okay. දැන් ඉස්කෝලේ පටන් වැඩ වැඩි තියෙන්නේ. ඕක එහෙම තමයි ඉතින්. මම තමයි ඉස්සරහ හැමදාම. අවුරුදු දෙකමාරකින් කට්ට පොඩ්ඩක් කන්න වෙනවා. කට්ටක් නෑ ආසාවෙන් කරන්න. Right. So with the school and other classes, other extra activities, you are doing sports maybe. So you need to somehow manage the academic with the sports or in other extracurricular activities, doesn't matter, but you need to manage the thing. So try to attend the live class, or the recordings are there. If it is really hard, go for the recordings. Okay, I mean, if you are not in the correct conditions, up to the that condition that you are physically, you are maybe not in the good condition now. මොකක් හරි අසනීපයක් වෙලා අමාරුවෙන් ඉන්නේ. ඒතර අපරාධන වෙලා පොඩක් නිදා ගන්න කමක් නැහැ. So okay, but then watch the video definitely before attend to next class. Otherwise, you are not getting the second day content without having the first day content. Okay, so actual vector for the naming, English capital letters are used. So remember that this is the way to name it. The naming. How did on the vector name this is vector AB. So there is another way. So if you want to represent the vector magnitude, you can use the modulus mark. So modulus mark can be used to represent the magnitude. Represent the magnitude. Because the modulus mark can. This is AB vector. I can use the modulus mark. The AB vector equals AB length. This is not a vector. This is modulus of vector AB. This is modulus of vector AB. That one equals AB length. A simple A. We know that length is simple A. Length is proportional to simple A. Okay. So this one is the way to represent the modulus mark, this double line. So this double line is the way to represent the modulus mark or the magnitude. Vector AB, modulus of the vector AB. How do you pronounce this one? Modulus of vector AB. Equals just AB, AB length, which is equal to the A. හරි modulus vector AB කියන්නේ මේකේ දිග ඒක. හරි. Okay. Okay, write that one. So modulus mark can be used. Used in can be used modulus mark can be used to represent the magnitude. Vector AB, modulus of vector AB equals AB length. Okay. Now you know the way to name it. Now you know to represent it. Hari. So Those things are there in your tute, I think. Okay. Yeah, good. Then අපි යමු vectors වලට. Hi. So now you know the way to mark the vectors. So now let's go to the actual vectors. Hi. Then up to this point we learned what is a vector, how do we mark a vector on a paper, on the book. So now let's move to the vector calculations, like how do you make that two vectors equal, how do you add two vectors, how do you get the difference between two vectors, what are the theories, how do we add a number of vectors, and එහෙම අපි වැඩ කරන්න යන්නේ. So first let's discuss equal vectors. Equal vectors. Okay. කොහොමද අපි දැන් හිතනවා you have that in numbers, you know, let's take x equals y. So if you take scale quantities, if you want to get these two equal, then number is just the value is enough. අපි හිතනවා මෙහෙම x y සමාන වෙන නම් as example 20 equals 20 නේ. If you want to make these two equal, their values should be equal. But in vectors, if you want to get two vectors equal vectors, there are certain principle, or not the principle, there are certain characteristics. Okay, you can write equal vectors. Equal vectors. Then equal vectors. Equal vectors. Let's say there are two vectors AB. Now you know this is a vector AB. The length of that one, just AB. Length of that one, vector AB length equals AB. Modulus of vector AB equals AB length. Modulus of vector AB is equal to AB. That is the way to represent the magnitude if you want. Okay, so there is the AB vector and there is another PQ vector. There is another PQ vector. Okay, there is another PQ vector. Then if those two are equal, if there are two equal vectors, or if you want to define two vectors having if there are two equal vectors, what are the things they need to follow, or what are the characteristics between them? And if they if to define two vectors as equal vectors, what are the characteristics followed by those? Give me one second. So draw this one and again. So for two vectors to be equal, magnitude. So if you take scalars, then the magnitudes are only the magnitudes, or the scalar magnitudes, or the size. Their size it should be equal. But when you take two vectors, two equal vectors, then its magnitude should be equal. Magnitude should be equal. Magnitude should be equal. Okay, you know, their magnitude should be equal. Vector AB equal to vector PQ. The concept is magnitude should be equal. Their direction should be equal. Direction කියන්නේ તો මෙයි parallel වෙන්න ඕන. If it is horizontal, this one also horizontal. If it is vertical, this one also vertical. If it is the theta angle, this one also should be the same theta angle. Parallel. Vector AB parallel to the PQ. AB line parallel to PQ line එකට. Other relationship is same sense of direction. All the things should be satisfied to define a vector equal vectors. Okay, මේකේ අදහස් තමයි if you want magnitude should be equal කියන. The idea of this one is magnitude should be equal. Here the idea behind this one is this is to represent the parallel. මෙහෙම ඉරි කැලක් දාන්නේ parallel කියන එක. හරි. මේ කියන්නේ AB, the idea behind this one is AB parallel PQ. The idea here, the direction should be equal. Same direction. Same direction. Parallel. Same direction. Another one is same sense of direction. There's another one, same type. ඒ කියන්නේ මේක force නම් මේක force වෙන්න ඕන. Otherwise, how do we get that? How do we make that vector? Let's take this velocity. Right? This is velocity and this one is force. That one makes I mean useless. I mean there is no meaning. If you are trying to make those two I mean homogeneous. I mean two they need to become homogeneous or same type. එහෙම වෙන්නත් ඕන. හරි homogeneous or same type. ඒක තියෙනවද මේකේ? Yes. ඒක තමයි මුලින්ම බලන්න ඕන අපි. Same type. Example, force. Velocity. Same type. ලියාගන්න. If you want to define two vectors like equal vectors, then their magnitude should be equal. Their what we call the magnitude should be equal. Their direction should be equal. Same sense of direction and same type. Same magnitude, same direction, same sense of direction, same type. ඔච්චරයි. So now let's move to the multiplication. ඉස්සෙල්ලාම අපි multiplication එකට ගිහින් යමු ලේසි අපිට ඒක. හරි. Let's move to multiplication and then we can move to the addition. The multiplication කරලා යමු. Okay. ලියාගත්තද? So remember that if you want to make those two equal, definitely there all these satisfy all these characteristics, all these requirements should be satisfied. Then you can write vector a b equals vector b. I mean නිකන් කියන්නේ හරි. Sometimes in maths you need this one. අපි කියමු there are two vectors having same direction but not the same size, same direction, same sense of direction. එකම line එකේ තියෙනවා අපි කියනවා dependent variable, dependent vectors කියලා. Dependent vectors, like let's say now there is a vector ab. As example, I mean you can represent a vector using other vector. Let's say you can represent bc vector using a k times vector ab. The magnitudes are not equal. K is just a scalar. Scale multiplication වගේ තමයි මේක ඒතකොට. හරි. If you can represent one vector for that, what are the requirements? So the magnitudes are not equal. Definitely the magnitudes are not equal. This let's take the magnitude of this one is a. We going to make a vector ab. So now we have a here we go. This is vector ab and you have vector bc. Right, vector bc. So now you can consider maybe හැමතිස්සෙම ඉලි කැලියක් ගහන්න ඕනේ නෑ, just a line enough. මම මේ mark කරන්නේ those are the two endings. හරි, no need to put that lines there, just a line is enough. Just line is enough, no need to put this bars. හරි, ඔහොම අදින්න තියෙන්නේ. So then let's say this is vector ab, this is vector bc, parallel same sense of direction. Okay, but magnitudes are different. Okay, but here we can represent this one is 2 times AB. Let's take the length of this one. Length එක හරි BC length equals 2 times AB. Since BC parallel to AB, we can write vector BC equal 2 times vector AB. If there are parallel vectors, if same direction and same sense direction both හරි දෙකම තියෙනවා B to C and A to B same sense of direction B to C and A to B. So then we can identify those two vectors dependent vectors. They are depending each other. BC is depending on AB. හරි සිංහලෙන් කියන්නේ පරායත්ත dependent no පරායත්ත දෛශික ස්වායත්ත භාවය පරායත්ත භාවය කියලා තියෙනවා. Dependent variable dependent vectors. හරි BC is depending on AB. තේරෙනවද මං කියන එක? So if you want you can write as example dependent variables කියලා දාන්න. Not variables, sorry, my bad. Dependent vectors. Vector dependency if you want. Dependent vectors. Vector one vector depends on the other one. One not equal. Equal means again like now the magnitude is also equal, but here magnitudes are not equal, but all the other things are equal. Same type. Same type. සමාන එකම type එක හරි. Same type. So then we can take BC is depending on AB simply. Or BC and AC can be considered as dependent vectors. Maths වලට ඕන ගොඩක් හරි ඒක ඉන්ඩිපෙන්ඩන්ට් ගතියක් තියෙනවා. දෛශික පරායත්ත භාවය සිංහලෙන් කියන්නේ පරායත්ත depend වෙනවා. පරපෝෂිත කියලා අහලා තියෙනවා. පරපෝෂිත කියන්නේ වෙන කෙනෙක් මත බඳා පවතිනවා. පරායත්ත භාවය. හරි. So vector BC can be represented as a k times vector AB. ඒ වගේම පරායත්ත කියන අනිත් එක සොයායත්ත independent. If you want to mark independent vectors, then they need to get perpendicular to each other. As example, you can take this one. So vector independent කියන වලින් independent vectors. ඒ කියන්නේ note කියලා දාගමු. No need to write heading. If you take two perpendicular vectors, මෙයා ඉන්නව මෙහෙම හරි. Maybe they are in same type, same force, but then the same type, same magnitude. But they are perpendicular to each other. හරි. ඒකේ ගොඩක් reasons තියෙනවා. Let's take there is a vector A here and there is another vector B here. Then vector A is not creating any effect to the vector B. If you take inclined vector A, then you can take the resolution කියලා අපි කියනවා කතා කරමු. So part of that one is acting to the this horizontal direction. So you can write that vector B and vector A somehow dependent. A වල part එකක් B වලට, but we can't say those are dependent because those are not fully dependent. No? But if there are perpendicular vectors, you can say those two are independent. දෙන්නට දෙන්න සම්බන්ධයක් නැහැ. මෙයා හිතන්නකෝ මෙයා කෙලින් යනවා මෙයා මෙහෙට අනිත් පැත්තට යනවා. This one is moving up vertical, this one is moving horizontal. They are never meeting. මේ දෙන්න කිසිම අදාළත්වයක් නැහැ. So let's say you have two friends. There are two friends. One is doing biology after the O levels, other one is doing commerce. They are in two different tracks. Biology and commerce. You are not meeting after the O levels sometimes. එහෙම තමයි ඉතින් හරි ජීවිතේ හැමදාම යාළුවෝ කියලා නෑ එක කාලේ එක කට්ටිය හම්බ වෙනවා යනවා එනවම තමයි. So then perpendicular vectors මේ ඔයගොල්ලෝ දැනුමට යමක් හරි. Perpendicular vectors are independent to each other. They are not creating any impact on the others. They are not creating any impact. A is not creating any impact to the vector B. So this is a symbolic expression. There is a vector A to upward direction. There is a vector B to this direction. එහෙම මාක් කරන්න පුළුවන්. හරි අවුලක් නැහැ. This is a vector A, this is a vector B. Those are two perpendicular directions. Complete. Additional note. Result ආවද? කියන්න බලන්න result එහෙනම් ළමයින්ගේ. සුබ පණිවිඩයක්. හරි දැන් කබල් වෙන්න එපා. හරි I'll give you 10 minutes break again. නැත්තම් මම දන්නවා you can't focus on this one. I know that. තාම නැද්ද? තාම නැත්තම් බය වෙන්න එපා. එහෙනම් ඔයගොල්ලෝ මේකට කන්සෙන්ට් කරනවා හරි නැත්තම් වෙක්ටර්ස් බැරි වෙනවා. O level වගේ නෙමෙයි A level. හරි O level නම් කවුරු ගණන් ගන්න A level නේ vectors අද today the first lesson. Okay. Result ආවේ නැද්ද හරි. හරි. ආවේ නැත්තම් කමක් නැහැ. ආවොත් කියන්න I'll give you 10 minutes break again to check your result. Otherwise what's happening you are not concentrating with my theory. දැන් අපෝ එන්න නේ යන්න එපා කොහෙවත් එන්න හිත එන්න අපෝ හිත ගන්න ළඟට take your mind again to your into your body. යනවා නැත්නම් එහා මෙහා යනවා හරි දැන් මොකක් වෙයිද? Okay, I know that feeling, but again focus. So you need to focus because since you are doing in online, definitely you need to have a self control to keep your focus onto the discussion, into the discussion. Otherwise it's moving here and there, you are not getting. Okay, ඊළඟට අපි යන්නේ දෙකක් දේවල් ඒකයි හරි. So note if there are two perpendicular, they are independent to each other. So this one is not creating any impact to the vector B. Those two perpendicular direction. So this one is known as vector dependency. If you can represent, I mean, if there are parallel vectors, you can write those are independent vectors. Vector dependency. Okay. So now let's try to go to the vector multiplication. Okay. හරි තාම කවුරුත් ඇවිල්ලා නැහැ. මම ඔයගොල්ලන් group එකේ බලන් ඉන්නේ main group එක. ඒකේ result ඇවිල්ලා නැහැ. මම આવොත් කියන්න. තාම මේ කට්ටිය බොරුවට බය වෙලා ඉතරලා ඉන්නේ. ඇවිල්ලා නැහැ. හරි. Okay. આવොත් මම දෙන්න interval එකක්. Okay. එතකොට result එක බලන්න. Now let's move to the vector multiplication. So when you take multiplication, first we can multiply a vector by scalar. So when you take multiplication, vector is now you know we have vector properties and scalar properties like numbers. So just a scalar 1, 2, 3, 4, whatever value. So what's happened if you multiply the vector by a scalar? Okay, vector multiplied by a scalar. So write down a heading. කට්ටිය බයලා ගියාද කොහෙද කීප දෙනෙක් කමක් නැහැ. හරි. result එනවා කිව්වම. So write down the heading. Okay, multiplication of vectors. Multiplication of vectors. Multiplication of vectors. Multiplication of vectors. So again, just write something like multiplication of vectors. So first you can see, first you can write multiplying a vector by scalar. Scalar multiplication, but I think that name is not correct. Okay. So we can write cross product multiplication vector is known as vector product, or give me a second, scalar product or dot product. Yeah, vector multiplying by a vector. Just write first one is multiplication of vector. We can analyze that one in two sections. Multiplying vector by scalar. Multiplying vector by a scale. First we are going to do that one. So then other one is vector multiply. Vector is multiplied by another vector. Vector multiplication, this is multiplication of vectors. So then vector multiplication. Or product between two vectors. Vector product. Vector product. Okay, vector තවත් vector එකකින් වැඩි කරන්න එහෙම පුළුවන්. So we can write vector product. Then product between two vectors. I'm generating a quick short mind map. Product between two vectors. Okay. So then when you take product between two vectors, we have dot product and cross product. We'll see those things later. There are two cases, cross product and dot product. Okay. So let's see those things later. So multiplication a vector by a හොඳම ටික අහගෙන හරිය දැන් හොඳම ටිකේ මයින්ඩ් එක එහාට මෙහාට යවන්න එපා. I need you fully focused to my class. බය වෙන්න ඉතින් මේ පොඩි ළමයි අය දැන් මේ ඒලවල කරන ළමයි. හරි. නෑ බය වෙන්න දෙයක් නෑ කවුරුත් ඕන කියන්නේ නෑ. කොහොම හරි හොඳ රිසල්ට් ඇති. Okay. මේවා ඕලෙවල් වගේ නෙමෙයි හරි ඒලවල් රිසල්ට් එද්දි. I know that feeling. The total of your life is depending on the A level. Total life goals, path depending on the A levels. A level සතුරු වෙන්න වැඩ කරන්න. Okay. So multiplying a vector by scalar. Multiplying a vector by scale, again another heading. Actually this one is nothing but vector dependency. vector dependency. So let's take there is a vector. On the vector dependency k only multiply karapinwane. Here I told you when you take vector dependency, there is a vector and you are multiplied by a scale. This is vector scalar multiplication. You can say vector is multiplied by a scalar. Vector is multiplied by a scalar. So vector dependency. So we can write there is a new vector PQ. You can let it there is a vector AB. There is a vector AB. There is a vector AB. And now you are multiplying by a scalar. Then actually what's happening? The magnitude changes. Or sometimes if you multiply by negative scalar, the direction also change. Right? So let's identify those separately. මෙච්චරයි කතන්දරේ. So first multiplying vector by scale ඒකෙත් අපි පොඩ්ඩක් මාතෘකාවක් දාමු special point එකක්. හරි. So let identify special point on that one under this section by a negative one. Negative sign. ටිකක් වැදගත් හින්දා වෙනම කියන්න. හරි. So multiplying a vector by scalar, so let's see negative multiplication, just -1. Okay, just -1. So we can write multiplying that is a scalar -1. First thing is so here our goal is to define something like this. We have a previous vector AB. We have vector AB. Now what we need to do, we need to take a new vector PQ, and that one is like k times AB. K times AB. So first point is if k is -1, k is -1. If k is negative, so simply multiply by negative sign. -1 means nothing happens to the magnitude, just minus sign. If k equals -1, if k was -1, ඔගොල්ලෝ group බල හදන්න එපා. මම group එක බලලා result આવුත් කියන්න. ඔගොල්ලෝ check කරලා ආවද අද ආවද දැන් ආවද එහෙම බලන්න මම ආවොත් කියන්න. I'm checking that group. හරි. ඔගොල්ලෝ බලන්න යන්න එපා. group එක බල ලොකුවට අද වෙන්න එපා. මේලයි පාඩම ඉගෙන ගන්න. සුන්දර පාඩමක අපි ඉන්නේ ඒකයි. So if k equals -1, multiplying by negative sign. So what's happening? So let's take there is a vector AB. And there's a vector AB. Actually, if you multiply by -1, so let's take this is vector AB. This is vector AB. You are trying to derive new vector PQ. Or just a negative vector multiplication. We can write that here. Let's say you are taking minus vector AB. -1 is -AB. Minus means it's minus multiplication means simply change direction. So we can write minus vector AB equals vector BA. Vector BA. Minus vector multiplication, let's take the k equals -1. -1 is minus AB. Minus vector AB equals vector BA. Vector BA can B වෙනස් වෙන්නේ නැහැ. හරි. A වෙනස් වෙන්නේ නැහැ. Those locations නේ. But your sense of direction change. Sense of direction change. So we can derive a new vector. There's a new vector. That one is going from B to A. මෙන්න මෙහෙම තමයි තියෙන්නේ දැන්. හරි. New vector PQ. නැත්නම් මම මෙහෙම දාන්න. This is the vector BA. This is the vector BA. This is the vector BA. Okay, so just write something like this. So if you convert or if you translate, I mean not translate, transform. If you transform a vector multiplied by a minus value, then its direction change, only the direction change. Emiliano. So this is the new vector, only the sense of direction change. හරි. මම පොඩක් confuse කරන්න යන්නේ PQ කියන එක. එතන මේක තමයි. So you can write, let's take vector PQ is a new vector. That one equals minus vector AB. Minus vector AB means is vector BA. So that means vector PQ equals vector BA. කියන්නේ vector PQ කියන්නේ මේකට. This is the vector PQ. Equal vectors. So this is the vector PQ. You can write here, just mark that this is the vector AB. Alright. So if you multiply the minus sign, only direction changes. Conclusion negative. Final conclusion negative. Direction change. Not direction, actually sense of direction. Sense of direction change when multiplied by minus the direction change. Change just means inverted actually. At the margin, not the magnitude. So now my goal is to derive new vector. So that new vector PQ, the new vector PQ, I am taking vector PQ is minus vector AB. So minus vector AB means BA. So PQ equals BA. මේක තමයි අලුත් එක. මෙතන vector PQ එක. Okay, ඒක තේරුණා නේද මම කියන එක? Did you get that point? අලුත් දේවල් නෙමෙයි, අමාරු දේවල් නෙමෙයි. So no need to get confused. So this is vector AB. So here if you multiply by minus, minus AB means BA. So I can write that vector PQ, new vector PQ. I'm taking new vector PQ. That vector PQ equals minus times vector AB loop. Minus 1. So then I can represent minus AB means BA. So then PQ equals BA. Anything to end them. This is vector PQ new vector after multiplying. This is the PQ vector. This will travel. Hurry, Berlin. Berlin. Hurry. Berlin. I'll give you 10 minutes break. ආපහු කමන්නේ. සතුරු අපිත් සතුරු වෙමුකෝ Berlin. So you can check the result and I'll give you 10 minutes again. Motivation video දාන්නද එකම video අහලා පාවෙන ඕගොල්ලන්ට ඊට පස්සේ. Okay. So just take 10 minutes and again check your result. සතුරු වෙලා ඉන්න ටක් ගාලා. I'll wait. Come on. කෝගලන් ගෲප් එකේ සද්ද බද්දයක් නැහැ. කට්ටිය එකවර සුදුහන් වුණා. I mean there is a main channel. There is no message in the main channel. Telegram. මෙච්චරලා message දාලා මේක එක්කෙනෙක් නැහැ. Okay, so tell me your marks now. Are you checking there? I'll wait 10 minutes. බලන්න හදිසියක් නැහැ. I'll put another video. අද එකම වීඩියෝ තමයි පෙන්නන්න තියෙන හැබැයි. ඔය බලලා ඔයගොල්ලෝ එපා වෙනවා. Yeah, I'll wait here. You can check. You can share your feelings with me also. කට්ටි සද්දබද නැත්තේ ලොක් වෙන්න බැරිත් තාම. Congratulations. හැමෝටම පේන්න දාන්න කියන්නේ ප්‍රශ්නයක් නැහැ. එතකොට කට්ටිය ඔයාලට congrats කරයි. whatever result doesn't matter 9 8 7 ප්‍රශ්නයක් නැහැ. එහෙමයි 9 ආවා කියන්නේ ඉතින් හොඳයි සතුටුයි. ඒ ගන්න පුළුවන් ලොකුම එක. I'll start the class at 10:10. Sorry 11:10. I'll start class at 11:10 නැත්නම් ඔයගොල්ලෝ මම දන්නවා. ඒ feeling I know that feeling. I also received that feeling once. I'll start the class at 11:10. යාළුවන්ට කියන්න. අපරාධ මට බ්‍රේක් එකෙන් මම දැනන් හිටියේ නම් බ්‍රේක් එක මේ වෙලාවට දෙනවා. කලින් දැනන් හිටියේ නෑනේ. අද විශ්වාස වෙනවා කි. ඕකේ. ආපහු මොටිවේෂන් වීඩියෝ එකක් දාන්න. You can chat with me මම බලන් ඉන්නේ. ඔයගොල්ලෝ ඉස්සර බලන්න හිමින් ඉස්සර ප්‍රශ්නයක් නෑ. ඕකේ වැඩ පටන් ගමු දැන් ඇතිනේ ආර්සල්ට ආවට පස්සේ භාගයක් ගිහින් ඕකේ හරි අපි වැඩේ පටන් ගමු otherwise it's getting late to finish this lesson මට ඉතින් ආපු වෙන දවසක කරන්න ඔයගොල්ලෝ අවුලක් නැහැ so හරි අපි වැඩේ පටන් ගමුනේ මට දුකයි දීපු කට්ටිය ගැන කරන්න දෙයක් නැහැ okay hari so let's start again I can put a message in the group I mean if they want to start join it again after celebrating now you can join to the class okay my result ඔගොල්ලෝ කැමති නම් කියන්න එහෙම අවුලක් නැහැ it's okay so because all the results not that much important for A levels I need your A level results හරි A level result තමයි ඕන අපිට හරි සතුරු වෙන්න පුළුවන් දුක් වෙන්න දෙයක් නැහැ මම ආවත් ප්‍රශ්නයක් නැහැ ෆේල් නැත්තම් එච්චරයි හරි ෆේල් නොත් කරන්න දෙයක් නැහැ again you need to do the main subject නේ yeah so let's start වැඩේ පටන් ගමු continue කරමු okay so learned the way that so today we are going to new, very fundamental concepts very important that's why I told you to always try to focus on this and because this is very important lesson but others hopefully they will get the recording at least okay doesn't matter I'll continue so now when you multiply it with the negative sign remember that you can change the direction so here AB this is BA so this is vector BA make pronounce කරන්න BA B ඉඳන් A ට okay so vector BA equals vector PQ so that is a new vector PQ now that is the negative multiplication so let's see what's happening when that K is changing with different values like you can write if K equals if K is greater than 0 greater than 1 K is greater than 1 if K is greater than 1 then අපි very positive values if K is greater than 1 means positive values so positive value doesn't change the direction but now you know as example what are the answers I mean what are the possible values for K greater than 1 2 3 10 2.5 let's take 12.2 like that there are so many values so if you multiply it by value like 2 3 what's happening only the magnitude change so this is my vector AB this is my vector AB this is vector AB so I need to derive new vector PQ but direction doesn't change but its size change ලොකු වෙනවා මෙයාට මෙයා ලොකු කරන් හරි when you draw the second vector with the higher length this is the vector AB you need to draw the vector PQ and its length should be increased because magnitude ලොකු වෙලා නැති this is vector PQ හරිද this is vector PQ equals K times vector AB okay did you get the concept write down this one ටක් ගාලා වැඩිට යමු let's say this is my vector AB so this is vector AB and this is final vector PQ as example its idea is magnitude increase same direction but same direction කටපාඩම් කරන්න එපා හරිය මේක එකට වඩා වැඩි නම් මොකද වෙන්නේ so what is the overall idea or if it is multiplied by negative value, negative ones, the direction change. If it is greater than 2 3, then definitely magnitude increase. ලොකු value එක වැඩි වෙනවා. හරි. It's increase, size increase. Earlier length is a, now the length is ka. මේක length එක 20, අපි යමු k is 2 කියලා. හරි. So then 2 times a is 40. This is 20 centimeter, 20 Newton. This is 40 Newton, like that. Okay. Complete this one. Then if k is still positive, that means greater than 0 but less than 1. What are the possible values? Half, 1 over 3, 1 over 4, etc. K equals 1 කියලා තේරුම් K equals 1 means then equal vectors PQ equals AB. Then same size, same direction. Okay. So let's take, we have two vectors like vector AB, but now you know what's happening. This K is a fraction. භාගයක්. ඒ කියන්නේ මේකෙන් භාගයක් වෙනවා. හරි. So this is vector AB. This is vector AB. All these things are in your tutor, so but come on, Eliano. So now we are transferring that one into a new vector. That one is smaller than this one also, but still same direction. This is the vector, new vector PQ. K times AB. K is a smaller value, so small magnitude. So you can write magnitude decreases but same direction. But same direction. එච්චරලා group එකක් තිබ්බ 28 කියලා ඒ group එක මැරෙන්න හැදුවනේ. දැන් silent. දැන් කාටවත් ගානක් නැහැ. අර මුහුදක් කෙනෙකුට මුහුදක් නේ සුනාමියක් කෙනෙකුට රැල්ල පිටිපස්සෙන් ආවා වගේ හෙන නියන් හෙන ഘോഷාවක් තිබ්බනේ. දැන් ආවට පස්සේ මොකුත් නැහැ. එහෙම තමයි හැමදේම. හරි. දැඟලිල්ල තියෙන්නේ වැඩේ කෙරෙනකන් විතරයි. කරාට පස්සේ දැඟලිල්ලක් නැහැ. Okay, so if k is greater than 0, less than, it's like fraction, positive fraction, but still positive, still positive, still positive, still positive. සතුට වෙන කට්ටිය සතුට වෙන, දුක් වෙන කට්ටිය පොඩ්ඩක් දුක් වෙලා අපෝ වැඩේට එන්න. මොකද ඒක ඔහොම නෙමෙයි දුක් වෙන්නේ ඒලොල් කෙලවනවා. හරි. ඒලොල් කෙලවෙනවා කියන්නේ කෙලිම ෆේල් වෙන්නේ. හරි. ඕලෙල් වගේ BCA නෙමෙයි එන්නේ. කෙලිම F එන්නේ. කරන්න බැරි කාට කෙලම් වෙලා යනවා. කරගන්නම් බෑ. කරන්න පුළුවන් කාට AB එනවා. බැරි එක්කෙනාට කෙලම් වෙලා යනවා. ඔය මැද්දේ නවතින්නේ නැහැ ගොඩක් වෙලා. canvas එසයක් ගන්න කට්ටිය ඉන්නවා. හරි. but 8 වැඩ කරපු කට්ටිය. S එන්නේ වැඩ කරපු කට්ටිය. If you want to get a S means above 35. That means 50. If you take 50, let's say you are taking 50 out of 100. Still, this one is in between 55 and 35. 8 SN. 8 SN. පේපරෙන් භාගයක් කරලා 8 SN. හරි. ඔයගොල්ලන්ට තේරෙයි පේපරෙන් භාගයක් කරන්න කොච්චර අමාරුද කියලා. ඔයගොල්ලන්ට දැම තේරෙන්නේ නැහැ. කරලා බලන්න. In A levels, if you want to get half of the paper, still it's very hard. බලන්න කීරවල. Then if that k value, k is the scalar, and I'm taking that k is less than -1. if k is less than -1, less than -1, ඒ කියන්නේ නිකන් as example k values are -2, -3, -10, -12.5, whatever. Minus value, minus means direction changing, value increase. Just take the number is increase. Number 2 3 4, it's like it's a positive integer, it's not positive integer. That one somehow the number as a value, as a magnitude, that one increase. But this the difference is now the direction also change. Right? So we can consider this is the vector AB. කටපාඩම් කරන්න එපා මෙවනේ හිතන්න. හරි මම මෙහෙම දුන්නට no need to memorize. When it is greater than 1, then direction increase. එහෙම හිතන්න එපා. Just think if it is the common final solution, what is the common characteristic? If you multiply by minus, whatever minus, direction change. If you multiply it with the higher number like 2, 3, 4, not it can be a fraction, but it's still greater than 1. 3 over 2 is a fraction. It's 1.5, 3 over 2 means 3 over 2. It's greater than 1. So if you take whatever value greater than 1 as a magnitude, then size increase. Magnitude vitrak, not the sign. Just take the number. So if you take a number, then its size it's have a higher value. It's having a higher value. These things are having higher values. So we can write A, B. The size increase, magnitude increase, the direction change. So this is the vector PQ. This is the vector PQ. When you compare the AB, now it is acting from B to A. B to A only. Not A to B, now it is B to A. This is the vector PQ. So what's happening? Magnitude increases and the direction also change. And the direction invert. And the sense of direction actually. But the same direction means sense of direction. Right? I'm implying the same sense of direction. Same sense of direction. It's inverted now. Change the direction. It's change the direction. So if you take a fraction with a negative value, I mean less than, it's greater than -1 but less than 0. What are the possible values like this? -half, -1/3, -1/4, like that. There's a minus term. Means there is a vector AB, whatever vector AB, and now you are getting small vector. Size of what you know. Hi, but the direction also change. This is P, this is Q. Vector PQ. Magnitude decreases and the sense of direction inverted. These are the possible cases that you can get. Complete this one. The same thing is in your tute, but complete. ඔයගොල්ලෝ සද්දවල නැති වුණා එකපාරට. ගෲප් වල ඉන්න ඕනේ නැහැ මේ මෙතන හිටපු කට්ටිය. මෙච්චර හොඳට හිටියා දැම්කෝ මේ දුකින් දෙද නෑනේ. කට්ටිය සද්දවද නැති වෙන එකපාරට. Okay, did you complete it? If you are still writing, please raise your hand. If you are still writing, please raise your hand. හරි ඩීල් ඉවරයි වගේ නේ කට්ටිය. Okay, so let's move to the vector multiplication. Vector multiplication. Vector multiplication. Okay. Vector multiplication. So write down the heading vector. So what is the final conclusion? What is the final conclusion? If it is multiplied by a minus, if it is multiplied by a minus, the direction change. If it is multiplied by minus, direction change. If it is if the forget the minus term. Forget the minus term. If you take the magnitude, if it is like greater than 1, then size increase. If it is less than 1, then size reduce. If it is a fraction less than 1, then less than 1, greater than 0. And magnitude wise, sorry, not the direction. So that is the final summary. No need to think like the section wise. Then final summary. If you multiply it by a value, large value, then magnitude increase. If you multiply it by a small value, means less than 1, its size reduce. If you multiply by minus, then direction change. Okay. So now we are going for vector multiplication or vector product or product between two vectors. Product between two vectors. Make ඕන වෙන්නේ නැහැ level physics වලට but maths වලට ඕන. Product between two vectors. For level physics you don't need that much. This one. So I'm taking two products, two vectors. So I'm taking two vectors like vector A and vector B. This is a way to represent the vector. No need to think like if you know the length of the 2 points like AB, if you know the length of that one as A, you can represent another way to name it vector A. This is the vector A. Or else you can mark, if you know the capital AB, then you can mark this is vector AB. This is vector AB. This is also okay. If you know the length, then you can mark vector A without using the capital block letters. These two options are there. If you know the two terminal points like AB, then you can mark vector AB. If you know the length as A, this is vector A. This is the vector A. Okay. Now I'm taking a vector, product of two vectors. Let's say there is a vector A. I would like to mark the same vector from the same point, vector B. Let's take there are two vectors. something like this. And this angle is theta, the angle between two vectors. There are two vectors, they are acting. This is not a better triangle, right? This is not a better triangle, not a better triangle. These are actual two vectors, actual two vectors. This is not a better triangle, right? Not a better diagram. This is not a better diagram. Triangle triangle. This is not a better diagram. This is actual two vectors acting on the vector A and vector B of force. This is also force. I just want to represent this is a vector quantity. This property is a vector. This property is a vector, and these are two same type. They are acting on a point with a certain theta angle. So then I need to take the product between those two. I need to get the product between those two. So there are two definitions. There are two definitions. One method is one concept. First concept is dot product. Dot product. ඒකට තව නමක් කියනවා scalar product කියලා. Scalar product, the idea behind this one is finally you are getting a scalar. That's the only thing you need to know as a LL physics student. When you take dot product, so the definition, the way that we are representing is A dot B. Vector A dot, as the name suggests, a dot product. Dot vector A dot vector B. Vector A dot vector B. Finally, this one gives a scalar. This is a vector. This is a vector. Finally, this one gives a final result is a scalar. ඒක තමයි කතන්දරේ. හරි. Vector result is scalar. So that's why it's known as scalar product. Okay. So, or dot product. It's very important. For physics, you need to know about that one. But that is the equation. I'll give the equation. Vector A dot vector B equals the magnitude of the vector A into magnitude of the vector B into cos theta. The cos value of this theta, angle between those two. This is the what we call the, for A-level maths, you need this equation. Hi, this is a magnitude, this is a magnitude, this is also a magnitude, this is a scalar. Make a magnitude, this is magnitude, scalar, final answer is scalar. This is the magnitude of vector A. So this is the no need for A-level physics. Maths, yes. Come on, but my own. Okay. Hi. No need. That's because of that. No need to put square bracket there. Make it. So this idea is very important. It's a scalar. This is the magnitude. This is the magnitude. This is the final. This is the final answer. Him expression and him. There is an equation like this. Vector A dot B can be represented as magnitude of vector A into magnitude of vector B into cos theta. Cos theta means the cost value of this angle. Okay, that is a dot product. I'm product chuttak 3D geometry, because you need that one for the magnetics. For the magnetics you need. So because of that, I'll explain 3D geometry a little bit. So this is the dot product. Finally, answer is scalar. Answer is scalar. මේක ඕනේ නැහැ. හරි මේක underline කරන්න ඕනේ නැහැ. This is the equation for mathematics I mean for the combined maths. Applied and applied, you need pure, applied, whatever, you need this dot product. Then what is cross product? So before going to cross product, I would like to add a note about 3D geometry. Hi. You know about the XY Cartesian plane, X, Y Cartesian plane. You are familiar with that one? XY Cartesian plane. This is XY. Okay. So then this is the XY Cartesian plane. So when you take the XY Cartesian plane, there is a, if you want to mark 3D nature, then you need to mark the Z axis. So normally to mark the Z axis, you can't mark whatever way. Someone can mark to into the plane or away from the plane. So how do you get the correct direction? You need to use the right hand split principle. Again, right hand split principle. X ඉඳන් y ට අත කරකවන්න. Then you can get the Z direction. මෙහෙම තමයි Z. Normally we are marking that way. හරි ඒක ඉතින් ලොකු අරලක් නෑ. එහෙම තමයි මාක් කරන්නේ x to y. So this is the direction of z. X to y. So this is a 3D geometry. 3D 1. Okay. So this is the xyz. ඒක ඉතර ඒක ලොකු අවුලක් නෑ. කියන්නේ කාටරි මෙහෙම මාක් කරන්න පුළුවන් but not the standard. This is standard xyz. You can rotate the other fingers x to y, then thumb shows the direction of the z. That's the standard way to mark the 3D graph. Okay, so this is 3D now. These are 3D. These are 3D. All the these are perpendicular components. Component perpendicular axis. Okay. Okay, so now there is another important thing. This is the XYZ plane. XYZ plane. And there is another property known as unit vector. And note එකම දාගන්න unit vector, unit vector, unit vector. In your note, add something known as unit vector. Note means some additional information. Unit vector. What is unit vector? Unit vector means a vector at the magnitude is 1. Unit vector is a vector having whatever vector, doesn't matter, there's a direction, having magnitude equals 1. Unit vector. ඒක සාමාන්‍යයෙන් මාක් කරන්නේ top එකකින් මෙහෙම hat එකක් දානවා. Unit vector normally we can mark as a hat. Okay. Unit vector hat. Symbol is the hat. Unit vector symbol is the hat. Symbol is the hat. U කියන එක මතක් කරන්න. U වල නැහැ. This one is the hat. So let's take now x direction. This is x direction. So if you take x hat, that means x hat කියලා ගත්තොත් that means there is a unit vector. There is a vector to that direction, and direction is parallel to the x. Magnitude is 1. I mean, now let's take here. I can take x hat. එහෙනම් මම මේකේ x hat කියලා මාක් කරොත් x hat කියලා කියන්නේ a parallel vector to the x direction. හරි. x hat means a parallel vector to x axis. And x axis and its magnitude is 1. So here we can write the symbolic expression is unit vector, whatever unit vector magnitude is equals 1. Alright. So I can take x hat is magnitude is 1. So it's somehow parallel vector. Okay. So if, as example, if you take a hat කියලා කියන්නේ, so here this is a නේ, this is let this is vector a පැත්තට තියෙන unit vector එක. ඒකක නැත්නම් ඒකක එයාගේ magnitude එක 1. Something like this. Magnitude is 1. Magnitude is 1. But parallel to the vector a, or parallel to the direction of a. Right. This is another symbolic, another symbol, another important point. Unit vector. What is unit vector? Unit vector means whatever vector having the magnitude is 1. Okay. Okay. So unit vector note එක. So now let's move to the cross product again. For the cross product, මේක තමයි එන්නේ. හරි. So now you can add the diagram again. Note එක ඉවරයි. So I am going for the I can draw the diagram AB, vector A and B. This is vector A, and here this is that object, and this is vector B. Okay, so this is the angle theta. So we have a cross product now. Cross product. Another name, vector product. Vector product, because final answer is a vector. It's known as vector product. Not product between two vectors, vector product. Because final answer you are getting a vector here. So as the name implies, cross, there is a cross. The symbol is cross. Okay, this is a vector. This is a vector. This is also a vector. Okay. And that one gives the result. That result also vector. Look. That result also vector. It's very important. Result is a vector. When you take a vector A cross vector B, final result is a vector. The correct equation of this one is maths කරන කටි ඉගෙන ගන්නෙත් නෑ. හරි. For A-level maths, you are not learning this equation. Vector A cross B. Vector A cross B equals vector A cross B equals vector A, magnitude of vector A into magnitude of vector B into sin theta into, we have defined something as neta, unit vector. මෙන්න මෙහෙම එකක් ගන්නවා. Unit vector of neta. හරි. So this is another, this is a scalar. This is a scalar. This is a scalar. But here this is a vector. So scalar multiplied by vector means again final result is vector. This is unit vector. Unit vector, what is this? What is this? Is neta. අපි A-level maths වලට 3D කතා කරන්නේ නැහැ. So because of that you are not getting this one for A-level maths. But why I'm teaching this one? For mathematics you need, there is a Biot-Savart equation. To explain the behavior of the Biot-Savart equation, I need this concept. එහෙම දන්නේ නැතුව උඩින් අත ගාලා යන්න පුළුවන්. We can teach you just without telling what's happening. This is the equation. Hi. So likewise, but to get the correct idea, it's not that bio කරන කටි bio නෙවෙයි, maths කරන කටි දන්නෙත් නැහැ. Maths students are also not dealing with these stuff. Not that much hard, but no need to memorize. මෙහෙමයක් තියෙනවා කියලා දැනගෙන විතරක් ඇති. So this is the magnitude of vector A. So this is another you don't need to derive it. This is a standard equation. This is a standard equation. A cross B equals වෙනවලු. This is standard equation, right? Vector මේක ආයෙ කොහෙන්ද? ඒක මම දුන්නේ. I'm writing this one because we can't prove it. And you can't prove it. There is equation, such equation. For A level physics, you don't need. There is such equation. This one is also for maths you need. For maths students, they need this one. Okay. So this is the expression. Magnitude, magnitude, magnitude. This is a vector. So final answer is a vector. So what's happening here? මොකද මේක imply කරන්නේ? What is this neta? This neta, you get a neta again. How do we pronounce this one? Neta. It's a great it's a alphabet. I mean, there is a letter coming from the Greek alphabet. Neta. Neta. This is the way to pronounce it. Neta. Okay. Neta. Alphabet, Greek alphabet letter. Neta. This neta is a perpendicular vector to both x and y. And neta bar hat is the unit vector for that direction. Neta is a vector. So you can write, we can calibrate now. Neta hat is a perpendicular unit vector to both x and y. This zeta y is a perpendicular unit vector. Magnitude is 1. Perpendicular to both x and y. කොහොමද x and y දෙකම perpendicular වෙන්නේ? Not x and y, sorry, my bad. A and B. A and B. A and B. Both A and B, not x and y. So how do we get A and B? So this is A, this is B. Then a perpendicular කවුද ඉන්නේ? මෙයාට perpendicular Z එක. The same Z. So this is something like this. Okay, so to get the direction A cross B, මුලින් ඉන්න එක්කෙනා තමයි A, then this is B. Always you need to curve your fingers from A to B. A to B curve කරලා, then you need to get the direction of the thumb to find the direction of neta. To find the direction of neta unit vector, curve the other finger of the right hand, from A to B. Because A nuling in A to B. From A to B, then thumb gives the direction of neta. Thumb gives the direction of the neta. Make concept go on. So then you need to curve your other fingers, like here I explain it. This is vector A. So you need to curve your other fingers, means this is my right hand. So from A to B, A in B, if you can't change the direction, like B to A it's a different one. So you need first, this is the A to A cross B. So direction matters. A cross B. So then you need to curve your other fingers from A to B. So then, so when you curve your other fingers, so you can get the perpendicular direction. So this is the direction of neta, and we are taking unit vector. A පැත්තට unit vector. So here this neta magnitude is 1 unit vector. So ඒක multiply වෙනවා මෙන්න මේකෙන්. So this magnitude of this one is 1. So 1 multiplied by this scale. This is scale. අපි මේක value 20 කියලා. එතකොට 20 වැඩි කිරීම 1 කියන්නේ finally 20. 20 කොහෙද තියෙන්නේ මේ පැත්තට. Let's take a magnitude of a as 1, magnitude of b as 10, then sin theta like half. Okay, so that is the answer 5. And then you need this neta magnitude is 1. Magnitude is 1. So then finally you are getting something like this, 5 Newton to this direction. Let's say this one is 30. I have example then I'll give something like that. Right. So remember the concept. ඒක ගොඩක් වැදගත් වෙනවා මේක මම ඉගෙනුවේ අපි කරන කාලේ ඉගෙන ගත්තේ නැහැ because for some cases like magnetics you need magnetics for 3D you need this one. So if you know the concept, if you know the fundamentals, it's easy for you. මම දන්නවා කියලා පෙන්නන්න නෙමෙයි කරේ හරි. I need this one for you because for magnetics you need Biot-Savart, for the Biot-Savart. So this is the direction of the neta and that magnitude of that one is 1. ඒක දිග එකයි. So this is a perpendicular vector, sorry. This one perpendicular is both A and B plane. So now liana perpendicular vectors both A and B plane. A and B plane. A B plane එක තලය අත ගන්න. හරි. So you can take the A and B just touch AB plane. So AB plane perpendicular. That means moving away from that one. So I can touch the AB plane. Plane එකෙන් තලය. හරි. I can touch the AB plane. So then that new vector, the direction of that one is A to B. It's moving out and perpendicular to both. That means something like this. කොහොමද ඉන්නේ ඕගොල්ලන් පැත්තට? ඕගොල්ලන් පැත්තට තියෙන්නේ කොහොමද? හරි. That is the direction of the new neta and the magnitude of that one is 1. Unique vector magnitude is 1. Direction if නෙමෙයි sorry my bad off. To find the direction of neta, curve the other fingers of the right hand from A to B. Here A to B. Then thumb gives the direction of neta. And the magnitude is 1. Okay. So then මේ maths කරනවා නෙමෙයි හරි මේ order you need to get a certain idea. And remember that because of this concept A cross B මේවා අහනවා MCQ වලට. These things are maybe these things might be the in MCQ questions. A cross B is not equal B cross A. Remember that, right? Here direction doesn't matter. Okay, මේකේ ප්‍රශ්නයක් නැහැ අපිට ඒක දාගන්න ඕන. So we can interchange the terms. A cross B කිව්වත් එකයි B cross sorry not cross dot දෙකම එකයි. Finally you are getting the same answer. When you take A cross B, then you are getting vector A in magnitude of the modulus of vector A modulus vector B into cos theta. Then when you take B dot A, the same thing. B A cos theta. Right? Same thing, but when you take the cross product, right? When you take the cross product, A cross B is not equal B cross A. What is the why is there? Because of this neta. Let's take now you are taking A something like this A and this is B and then you are taking A cross B. So A cross B means this, you are curving your other thing from A to B. Then this is the direction of the neta. This is the direction of the neta. Okay. So if you take B, this is A cross B. Okay. So now when you take B cross A, same magnitude, yes, same magnitude, magnitude saman hai, but direction change. That because of that we can't say these are equal. This is a vector, this is a vector. Vectors දෙක සමාන වෙන්නේ නැහැ. This is because of the direction. This is A, this is B. You are taking B cross A. කියන්නේ මෙහෙට තමයි කරකවන්න ඕන ඇඟිල්ල. අත. You need to curve your other finger from B to A. First B is there. So then you can see that a new direction is something like this. This is the direction of theta. Perpendicular. Into the plane. ඇත්තම තව මාක් කරන විදිහක් තියෙනවා. හරි. So when you take arrow, if you are observing from the forward side, you can see a dot. If you observe from the rear side, you can see a cross. පිටිපස්සෙන් බලද්දී. Okay. So because of that, so for 3D geometry, you can see this one as a dot. Elliott line is moving away from the plane. This neta, if, although I mark in this way, you can see that neta is a dot. It's moving away from ආට පේන්නේ ඊතල ඉස්සරහා. හරි. It's moving away from the plane. When you curve your other fingers, I'll mark in that way. It's easy for us then. You can feel what's happening. So you can see this one when you mark A across B, you can see your neta as a dot. Hi. Moving away from the plane. Here you can see your neta, direction of the neta as a cross. Curve, then you can feel it's moving into the plane. Moving into the plane. So arrow ke පිටිපස්ස පේන්න ඕගොල්ලන්ට. Arrow ke පිටිපස්ස පේන්න. You can see the rear side of the arrow. Okay. So this one moving into the plane. Moving into the plane. So remember the concept. Arrow එක ඉස්සරහා තමයි අපි ගන්නෙ. හරි. Normally dot එක විදියට. For 3D geometry, this is the way to mark the 3D geometry. Okay. So because of that, your final answers are different. This one is you need to know. For cross product, you can't interchange the term. A cross B not equal B cross A. This is equal, this is not equal. This is not equal sign. Okay. Then let's do a simple calculation. කොහොමද දාගන්න හරි? ඉතින් ආරවාස් කට්ටිය සද්දයක් කරන්න හුම්මත් නැහැ. හොඳයි. So are you still writing? So please raise your hand if you're writing. හරිද? එහෙනම් කවුරු අතුස්සරනේ. Okay, so let's do a small question. Q. So I'm taking there is a object. There are two vectors acting on that one. Let's take forces. Let's take ප්‍රශ්නයක් නෑ, you can take whatever you want. 3 Newton. Hi. This one is 4 Newton. This and also remember that when you take vector multiplication, no need to have the same vectors. Right? You need to take two different vectors also. You can multiply. But scalar multiplication වලට එහෙම බෑ. හරි. හරි, come on, hang in. Right. Okay. For the scalar multiplication you can't. Right on 12 කරන්න ගියානේ. අනේ like a signal to end the class. වගේ ඔයගොල්ලෝ එහෙම හිතුවද ප්‍රාර්ථනා කරලා විශ් කරාද අද ඉක්මනට ඉවර කරන්න. Okay. So අද රිසල්ට් ඇවිල්ලා තියෙන ඉක්මනට මේ enjoy එක celebrate කරන්න ඕන. Where is it? Okay. Here, if you want to scale multiply, definitely these two vectors should be the same type. Hi. Make a force together. Force එක 2 වලින් වැඩි කරොත් then again you are getting the force. තේරෙනවද මං කියන එක? There is a speed or not speed, velocity. If you multiply it by the scalar, again you are getting a velocity. You are getting the same type. I told you that vector dependency, same vector, same type. But when you take vector these two, මේගොල්ලෝ එකම vector එක වෙන්න ඕනේ නෑ. You can take two different vector like force into area. No, so not area. Force into displacement. Force into displacement. Force into displacement. ඇත්තටම force into displacement වෙන්නේ work එක. හරි. Then work is this one. Dot product. Force into displacement, you are getting a scalar. So force into displacement, no need to have the same property. So as example, for this one, you are getting force into displacement like this one. Force into displacement. හරිද? දැන් මම එහෙම example එකක් දෙන dot product එකේ. So they don't need to get the same one, same property. Okay, හැට මෙහෙර ගන්න ගියාම හරි. මම example එකක් දෙන්න. ලස්සන ලියන්න හරි note එක. So let's take there is a for at the example then example. So let's say there is a box. And you are applying because the displacement mark करने पे ना भी तो क्या खड़ रहेगा. So come on, it's okay. So let's say you are applying a force 4 Newton force. F equals 4 Newton. And you are applying continuously, and you can do a displacement. So this is the displacement. Okay, so let's say this force is inclined force. This force is inclined. This is the 4 Newton. Let's take angle is 30. So this is a displacement. Let's take the displacement 10 Newton. This is a displacement. This is a displacement. Direction right? This is the displacement. I'm taking some real world application. Right. So I'm continuously applying this 4 Newton like this. So then we have a new property known as work. Hi. අපි ගාලු property එකක් තියෙනවා ඒක මෙහෙම තමයි define කරන්නේ. So we have a new property known as force, work. හරි. ඒගොල්ලෝ කියන මේ work කියන එක එන්නේ work. That work W, that one always come as a dot product. F, vector F. හරි. අපි කොහොම ඉගෙන ගන්න නෑ පන්තියේදී vector F into displacement. It's a dot product. Okay. So you can write this is the work equation. It's a dot product between those two. So now if you mark the two vectors in the same vector diagram, this is a displacement. This is a displacement 10 Newton, and this is the force 4 Newton, and this angle is 30. And I'm just marking the two vectors on the same position. I can mark like this, doesn't matter. This is 4 Newton force, and this one is not Newton, sorry. Newton kill them. Meters. This is a displacement. Meters. 10 meters. Okay. So force into displacement is a dot product. So the final answer මොකක්ද දෙන්නේ? So you know that F dot S equal F වල එකයි S වල magnitude එකයි cos theta. So what is the F value? What is the F value? හරි, F එක එන්නේ 4. The S value is 10. What is cos? අපි 60 කියලා ගමු. පොඩ්ඩකින් ලේසි වෙන්නේ. Let's take that one as 60. 60 all 30 කියලා ඉවරන කමක් නැහැ. හරි. Just write that one as 60. Then cos 60. Then you can write cos 60 means half. I'll do that one. I'll explain that one. It's a new mathematical introduction. So then 20 Newton. Cos 60 means half. If you take cos 30, this is root 3 by 2. Then there is another root 3 here. Hi. So this is the final answer. Work in. So you can mark. This is a dot product between two vectors. This is the actual equation for the work. But අපි ඔක ඉගෙන ගන්න නැහැ මේ physics වල හොය විදිහට. So normally අපි ඉගෙන ගන්නේ as a equation fs cos theta කියලා ඉගෙන ගන්නවා කෙලින්ම. fs cos theta. හරි. So then we are not learning in this way, but actually work is a dot product between two vectors. Work is a dot product between two vectors. Okay. This is displacement. So this is a dot product example. Dot product example. Making a period of making daagam. So with the vector multiplication, let's stop. Newton Newton meter. This is Newton, this is meter. So Newton meter. Newton meters means joules. Newton meter means joules. So 20 joules. This is Newton, this is meter, Newton meter. This is just a fraction. So Newton meter 20 joules. Sorry for that mistake. So finally, the correct equation for the work is F dot S. But in mechanics, we are not learning in that way. But here I just want to explain about the correct equation of the work. So you can see we can take a dot product between two different properties. We can get dot product. Finally, answer is a scalar property. It's a scalar one. No direction. No direction. Just 20 is a scale property. The work is a scalar one. Okay. Then let's take cross product equation. Cross product. This is scalar. This is not scalar. Again, final answer is scalar. This is dot product. Then මම example දෙනවා torque equation එක. So this is the work equation. Example dot product එකක් කරේ හරි. This is example for dot product. Actually work equation, work කියන එක. Now I am giving a cross product example. Cross product. Actual example regarding torque. Regarding torque. Hi. Torque කියලා කියන්නේ කරකවන ගූරුන ගන්න scene එකක් තියෙනවා. හරි. So let's take now there is a pivot object here. There is a pivoted object. Let's say there is a rod. that rod is pivoted through this point. This rod is pivoted through this point. Pivot කරලා තියෙන, high කරලා තියෙන, pivot point. And there is a weight. You bar force එකක් තියෙනවා මෙහෙම. Weight එක. There is a force, weight. And then distance, let's take r, the perpendicular distance between the line of action of the force and the pivoted point. There, that is the equation for the torque. Hari. So the concept is, always remember that the torque, when you take the torque, tau equals, the r is a displacement. Hari. R is a displacement. This r is a displacement. Actually, r is a displacement. You need, is a vector property. R distance එකක් නෙවෙයි, displacement එකක් වගේ තමයි. It's also a vector property. R is a vector property. F is also a vector property. මේ directions mark කරලා දෙන්න. F is downward. This is like this. මම කියන්නේ මෙතන මම mark කරේ as a vector property. හරි. මෙතන vector එක. Displacement as a vector. This force as a vector. So now when you take the torque, and torque එක එන්නේ ඒගොල්ලෝ කියන equation එක force as a vector into r as a vector into means cross product. මොකද වෙන්නේ? Tau. Think Greek alphabet tau. Tau. Tau කියලා කියන්නේ tau. Symbol එක tau. මොකද වෙන්නේ? හරි. So මොකද වෙන්නේ? So let's take some example like force is 40 Newton. This one is this distance is like 2 centimeter. R 2 centimeter. So then we can write force into this one. You know that equation is magnitude of force into magnitude of these are just scalar. Right? R unit vector. So not unit r vector, magnitude of the r vector, magnitude of force vector. Then sine theta between those two. Sine theta between those two into neta unit vector. පොඩ ඇද කරලා ගත්තා නම් තව ලේසි මේ ප්‍රශ්න. මම මේ perpendicular නරන් තියෙන්නේ. කමක් නැහැ. So in this case your f and r is perpendicular, theta is 90. This is your vector r. Right? And vector r vector එහෙම දාන්න. cap simple letters දාන්න මෙහෙම. කමක් නැහැ. This is okay. That's never mind. අවුල නැහැ. It's okay. එහෙම දැම්මක් කමක් නැහැ. Normally simple letters උඩින් දානවා අඩුයි, but දාන තැනුත් තියෙනවා කමක් නැහැ. It's okay. You can mark arrow above the simple letters. Okay, doesn't matter. එහෙම දාන තැන තියෙනවා. හරි. So this is a vector. R is a vector, is a displacement. So මෙහෙම ඉගෙන ගන්න නැහැ මේ in the mechanics. So this is R, this is F. So then this one I can take 2 centimeter. So now what we can do, if you mark that one, this is your F. So this is your R vector. And this is your F vector. This is 90. This is 90. Okay. Sine 90 එන්නේ. එතකොට උදේ එන්නේ අපිට F එක එන්නේ 40. R එක I would need to convert the SI unit. Centimeter to 10 to the minus 2 meters into, this is SI unit, right? This is in meters now. Into sin theta is sin 90 actually. That is the magnitude into neta unit vector. So then this one finally you can get 0.8. This one is actually 1 into neta unit vector. So finally answer the magnitude of the tau. Magnitude of the tau is this. This one is C1. The magnitude of this one is 1. So then 0.8 Newton meter තමයි. What is the direction of the tau? This is Newton meter because Newton meter. This is torque. Then how do you find the direction of the torque? Direction of the torque. You need to apply your, right? So here, so this is your direction of the torque. Direction of the torque. You need to apply your, right? So here, so this is your direction of the torque. Direction of the torque. You need to apply your, right? So here, so this is your direction of the torque. Direction of the torque. You need to apply your, right? So here, so this is your direction of the torque. Direction of the torque. You need to apply your, right? So here, so this is your direction of the torque. Direction of the torque. You need to apply your, right? So here, so this is your direction of the torque. Direction of the torque. You need to apply your, right? So here, so this is your direction of the torque. Direction of the torque. You need to apply your, right? So here, so this is your direction of the torque. Direction of the torque. You need to apply your, right? So here, so this is your direction of the torque. Direction of the torque. You need to apply your, right? So here, so this is your direction of the torque. Direction of the torque. You need to apply your, right? So here, so this is your direction of the torque. Direction of the torque. You need to apply your, right? So here, so this is your direction of the torque. Direction of the torque. You need to apply your, right? So here, so this is your direc හරි F into R නේ. පොඩ්ඩකින් හරි how do you get direction පොඩ්ඩක් මම හිතන්නේ වැරද්දුවා මොකක් හරි you need to mark in this way F එකේ ඉඳන් නිකන් හරකවන්න ඕන R පැත්තට නෑ give me one second I did a mistake here but mark this one මේක බලන්න මේක හරි මේ උත්තරේ හරි then what is the direction of the torque you need to apply right hand screw principle again හරි so write this one අමතර දෙයක් කරන්න ගියේ මම කවන්නේ ලියන්නු නෑ මේක අනිත් පැත්තට තියෙන my bad ඒක තමයි බැලුවේ correct equation this one is not correct ඒක තියෙන අනිත් පැත්තට ඒකට හදාගන්න R into F R into F not FR R into F R into F හරි this is the R vector into F vector මේක ප්‍රශ්නයක් නෑ you can keep it like that doesn't matter මේක වෙනස් කරන්න ඕනේ නෑ වෙනස් කරත් කමක් නෑ මේක වෙනස් කරගන්න හරි this one is R into F R into F because direction matters I told you if you invert the direction totally you are getting opposite one direction change this one should be this is the correct I googled it this is the correct equation for the torque බලන්න මම මේ කියනනේ Google කරලා බලන්න torque equation R cross product there is a cross product so if you take the this is R this is F so you need to curve the other fingers from R to F R ඉඳන් F එකෙන් කරකවන්න ඕන R in F එකකට you can see that one as a cross ඇතුළට තියෙන්නේ then your torque direction is cross I told you if you want to get the direction of the cross product always you need to curve the other fingers from first one to the second one then you can see a cross so actually the directional torque is cross for the ඇතුළට තියෙන්නේ this neta indicate the direction actually is magnitude is 0.8 magnitude is 0.8 yes that finally what is the torque එක ඉන්නේ 0.8 newton meter into the plane for the ඇතුළට magnitude is 0.8 when you take the magnitude this neta doesn't involve with this one because that needed magnitude is 1 that one only change the direction don't pay on it then if you mark this one as F into R then I am getting a dot F into R dot again that one is incorrect if you take F into R that one gives a dot same magnitude 0.8 but magnitude is dot direction is dot that is incorrect that is not the actual direction of the torque actual direction you need to take as a cross this is the equation for the torque so that one is F and R you can see it's into the plane so actual equation that we are using in physics but අපි ඉගෙන ගන්නකොට මෙහෙම ඉගෙන ගන්න නෑ we are not using these symbols when you are learning mechanics but this is the real physics so example for cross product you can get the torque example dot product so you can see here this is displacement this is a force when you multiplied you are getting a torque newton meter but this one is not joule for torque moment of force you can't use joules so these are some examples real world examples for what we called position vector මේකට කියන්නේ position vector කියලා displacement can be defined as position vector this is position vector and the force vector this R is a position vector or this position vector this one Google බලන්න මම මේ කියනව නෙමෙයි. I'm showing the real world physics, not simplified version. අපි simplified version වලට ඉගෙන ගන්නවා. හරි. You can go for simplified versions like talk. මම මේ කියන්නේ පරම සත්‍ය. පරම සත්‍ය ඉගෙන ගන්න ඕන සමහර තැන්වලදී පරම සත්‍ය ඒ උදව් වෙනවා. අර පරම සත්‍ය දන්නවා නම් you can manage with whatever you want. නැත්තම් හරි අමාරුයි පට්ට අමාරුයි කියලා දෙනවා හොඳ නෑ. අපි වැඩක් නැතිව කියලා දෙනවා. හරි. එහෙම නෙමෙයි. I'm just teaching you these things because for some cases you need that knowledge to get the answer for physics like certain like statement wise question. Hi, meeting. Tau equals R cross F. So the equation of calculate tau depends on the variable you are measuring. Okay. So here the cross product of the position vector and the force vector. So these are real world physics. So we can get a simplified version. Right? We can get a simplified version. But to get the direction, definitely we need to use the what we called we need to get the right hand screw principle. Right hand screw principle. මම මෙතන sin theta එක දාගන්න මට උමනාවක් වුණේ නැහැ. Here I used in that example I used the perpendicular cases. හරි. එහෙනම් sin theta මට ඕන sin theta මේ කියන්නේ with the cross product. Sin theta comes from cross product. හරි. මේ හැම එකම එහෙම තමයි බලන්න මාර ලීසි මේවා ඉගෙන ගත්තා හරියට හරි. But here in when you are learning mechanics we are going to learn some simplified version, but these are the actual equations. Hi, this is the work actual equation. Work is dot product between force and the displacement or position vector. ඒක ප්‍රශ්නයක් නැහැ direction change වෙනවා. හරි, you can write f dot s කිව්වත් එකයි s dot f කිව්වත් එකයි same. But here direction matters. Direction matters. Because this one final answer is a vector. Final answer is a vector. Final answer is a vector. Okay. හරි තේරුණා scene එක. වැඩි. වැඩි හොඳටම separate තේරුණු කට්ටිය අතුස්සන් බෑ. So please raise your hand if you learn this concept. So dot product cross product. So if you remove that dot for cross product, you can't interchange. I mean, if you interchange the direction change, that means you are getting a new vector. I mean, with the magnitude yes, but the different direction means a different vector. හරිනේ? Okay. So remember the concept. So මේකම හදාගන්න R vector into F vector. These things are same. So this is the direction of the toe, the torque. අතුස්සන් බෑ කො හරියට වැඩේ තේරුණා අම්බෝ අද නම් කරා අමාරු වගේ මොනවද මේ තේරෙන්නෙත් නැහැ එහෙමද අන්තිම ටික ඔව් අතුස්සන් නැහැ නිකව why didn't you get that one? So watch the video again. මම දැන් විසාලට ආවට පස්සේ මොනව වුණාද කියලා ළමයින්ට මේ වන්දා අධ්‍යාපනයක්වත් නැහැ මම කියන එක ඇහෙනව නේද? Is it hard? If it is really hard, then tell me. I'll okay. First, go through the video. Go through the video. Complete the note and tell me next day before starting the next new section. So we are going for the vector addition now. We are going for vector addition. Right? We are going for vector addition. So I'm explaining the real world physics before going to the simplified version. You can learn the simplified version. These are standard equation for the work and the torque. Right? But no need remember in this way. So we are going to learn some simplified version when you are learning mechanics. So remember the concept, but complete your note. So watch the recording and complete your note. If you are not apply your maximum, not maximum, if you are not apply your full focus due to the result, then watch it again and complete. Okay. So I explained about the vector product. එකපාරට අද පටන් ගන්නකොට නම් හරි ලේසි තිබ්බා අන්තිම වෙද්දි හිනම මොනවද මේ symbols ලියලා මොනවද මේ නිකන් එහෙම අප්සෙට් නෑ එහෙම නෑ ලේසි හරි. So learn that one again. If you miss the focus, I mean if the focus is if you're not applying the maximum, if you're not applying the focus entirely to this one, definitely you are not getting the concept. So because of that, again watch the recording and somehow complete the note. And also if you have doubts, then please ask before starting the next section. So I explained what is cross product, and then what is dot product. So I told you, at least remember vector, finally you are getting scale. Okay, so I added a note here. This is a note. Before going to the other one, I explained this x, y, z, a 3D geometry, and what is unit vector. තව පොඩි දෙයක් කියලා. When you take two perpendicular one, a dot b is a cross a dot b is 0. When you take two perpendicular vectors, a dot b for two perpendicular vectors, එකක් පොඩි note එකක් දාගමු. දැන් මට මතකයි අපි marking හදද්දී, when you are creating marking for certain questions, we are using those principles. maths වලට වගේ ලොකුවට නැහැ, ඒවත් ඒව ඕනේ නම a dot b is a dot කියන එක. sorry, a dot b is a 90. a dot b is 0 කියන එක for 90. So at that one also another example. So let's say we have vector a and vector b, those are perpendicular to each other. So when you take the a dot b, then magnitude of a, magnitude of b, then this one is cos 90. Cos 90 is 0. This one is 0. A dot b is 0. That means two perpendicular vectors, the dot product is 0. Okay, අනිත් පැත්ත ගොඩක් විභාගය ඕන වෙනවා. හරි. If you take a dot b, if you can identify a dot b equals 0, that means vector a and vector b are perpendicular. This one also very important. I mean, if it is perpendicular, a dot b is equal to 0, but somehow let's take there is a statement. When you take a dot b equals 0, then vector a and vector b, they are these are perpendicular. අනිත් පැත්තට මාට වටිනවා ඕනේ නෝ. Okay, but for cross one you can't write like that. Cross එකක් තියෙනවා හරි, a cross b, then this something like this, a cross b dot එකක් එන්නේ, a cross b. Okay, write down that example also for regarding the dot product. Dot product of two perpendicular vectors. Perpendicular vectors. මම මේ උගන්වන්නේ සිලබස් එකේ නෑනේ. මේ cross product එක maths වලට නැත්තම් උගන්වන්නේ කියලා. මම මේ පෙන්නන්නේ how these things are involved with real world physics, and for some cases you need that one. දැන් මට බයෝසාවර්ට් එකේදී ඩිරෙක්ෂන් හදාන්න විදිය කියලා දෙන්නාම I need the cross product. Again I will explain that one later. So ඒ වෙදී මේ මතක නෑනේ, so I will again, normally I'm again explaining, but at least remember that there are two cases like dot product, cross product. So when you take dot product or cross product, you can take the dot product or cross product between any properties. ඒ දෙක සමාන වෙන්න ඕනේ නැහැ. You don't need to get the same type. No need to get the same type. Hi, this is force displacement. This is also force displacement, position vector. Okay, but finally you are getting a scalar here. You are getting a vector. This is a vector. This is the direction of that. Finally, this one is a vector. හරි. So හිමින් සීරුවේ වැඩේ කරගෙන යන්න. හරි. අද පොඩ්ඩක් පරක් වුණා because of that thing. ඔයගොල්ලෝගේ result එක හින්දා නැත්තම් මම 12ට ඉවර කරනවා. Sorry for that delay, but I need to finish this one up to the multiplication. So next week we are going to addition. The multiplication නම් easy. හරි. Nothing we are not going to develop, I mean we are not learning beyond that point. Etc. I am known now, but learn the physics. I'm not going to do the calculation. My calculation based I just want to explain the physics part. The equations are also given from the physics, real world physics equations. But I need to know, you need to know about that. A cross B is not equal B cross A. And also, finally, you are getting a vector. Vector, cross product is a vector. And the direction, order is hard. Okay, so we'll stop at this point. මං හිතන ඔයගොල්ලෝ අද නම් එනම හැපි එකේ හරි මොකක් හරි වෙනසක් තියෙනවා. කමන්නේ. So we started the first lesson regarding the vector. So this is day 1 for the vector. So we can move to the day 2 next day regarding the addition. So addition එක සුපිරි. Addition තමයි අපිට ඕනම physics වලදී ඕනම addition. Addition means vector addition. Resultant vector. That's the most important thing in vectors. So we are using different like parallelogram law, vector triangle, then resolution, vector resolution, resolve කරනවා. Right. So using that method, how do you get the resultant vector? There's a gonna homework නැහැ අදට because all the things, all the homeworks are based on the vector addition. Addition කරේ නැහැ. So no homework for today class. So we'll start that addition by next week. From the next week. Okay, so I'll stop at this point. So see you on the next day. Okay then. If you have any question, you can ask. Or otherwise, we can finish the class. So no need to worry about your all results. So this is a new journey. It's a new path, and this one changed the entire your future based on the LO result. So always whatever result, maybe 9 A's, 8 A's, 7, 6, මොකක් හරි වැඩක් නැහැ. 9 A's නම් fail වෙන කට්ටිය ඉන්න ඕන තරම් A level. හරි, I need better A level result. Okay. මම මෙහෙම කියන්නේ ඔයගොල්ලෝ හිතන තරම් නෙමෙයි, ඇත්ත කතන්දරය. හරි 9 A's ගත්ත කියලා අපි කොහොම පුළුවන් වෙන්නේ නැහැ A level වලදී. fail වෙලා යන්න. එන කට්ටිය ඉන්නවා කියන්නේ හැමෝම fail වෙනව නෙමෙයි, 9 A's ගන්න ඔක්කොම fail. එහෙම නෙමෙයි මම කියන්නේ. 9 A's ගන්න කට්ටියත් fail වෙනවා. ඕල් ABC කැත එහෙම තියෙන කට්ටිය 3S ගන්නවා. Okay, so always think positive and work hard in A levels. So if you are not happy about your A level result, then think in positive and work hard in A levels. This is a different journey. So you can learn. Now you have a motivation. So start your new journey and always try to win the game. Okay, so then let's stop. So see you on the next day. Bye. Good night.